Well, good morning, everyone. Welcome to the 12th Annual Future of Automotive IT Conference, sponsored by the Automotive Futures Group, of which I am the Managing Director. My name is Bruce Belzowski. I'm the host today for our conference, and we have some wonderful speakers to be able to talk about the many different aspects of the Internet of Things in the automotive industry. We'll probably, and as we always do, try to stay focused on what's kind of going on currently, and also a peek into the future about what people think is going to be happening in the near term. We've got a number of speakers. We've kind of looked at this from different perspectives of researchers as well as practitioners. And we're looking forward to hearing what the both groups had to say about where this technology is going in the automotive industry. I'm going to start off with some information about our group and what we're doing here at the Automotive Futures Group, and do a little intro into the kind of setup for the topic of automotive IT. And so I want to start out by again thanking everybody for attending. The Automotive Futures Group, we've been in existence for about different organizations within the University of Michigan since the mid-1990s. Our funding comes from our affiliate program. We'll talk a little bit about that. Our research is focused on globalization and the powertrains and advanced powertrains and ITS / intelligent transportation systems, and our 5 annual conferences that we're looking at working on right now. This being one of them. This is our 12th annual, as I said, the Future of Automotive IT. We couldn't do any of this stuff without our affiliate members, and there's always we always like to give a shout out to our affiliate members here listed on this slide. Want to thank them for their support. Our research partners across IT organizations, OEMs, government NGOs, as well as manufacturers and suppliers and consultants. Some of our projects that we're working on this year is our powertrain strategies for the 21st century survey that we talked about in our conference in July. Our China New Energy Vehicle project that is kind of morphed into the global EV project that we're working on right now. The effects of autonomous vehicles on the economy, society, and the individual project that we're working on with colleagues from Switzerland and China. Some of the research questions that we're focusing on, some of them we've been addressing. The pandemic has put some of these on hold for the moment. But we've been addressing some of the mobility powertrain questions, of course, that we talked about in our July conference. Globalization was part of our discussion in last April on the globalization of the automotive industry and the pandemic. I'd like to introduce some of our researchers. Kara Alkire, she's online today. She works on the conferences as well as our student researchers, Wei-Chen Li, Rishi Chen, Daniel Nemert, and Lahari Vavilala. They're working on the different projects that we have going on, and looking forward to continuing working on them this year. This is the beginning of the school year. We try to look at our funding works on a school year as well. So we're really beginning our school year and our research this year. One of the things that we're doing over the past summer was developing our LinkedIn Automotive Futures Group. And if you have any, many of you have already are connected to the LinkedIn page. If not, we'll be sending you some invitations to join us. We've been putting out 2 or 3 things a week, trying to keep things fresh on the internet and LinkedIn, about what we're doing, what we see happening in the industry, advertisements for the upcoming conferences. Hopefully you can join us on this. Next upcoming conference is November, Inside China. This will be our 13th annual Inside China conference. This is the first conference that we started back in the early 2000s. February, we're doing new mobility. We're looking at goods movement this time. We're not sure. It's a tentative topic. We're having April open. Depending on what's going on in the industry, we'd like to keep one open date to see if there's a hot topic that we want to address. We did it this spring with the pandemic. And in July, we'll again do our 13th annual Powertrain Strategies conference. One of the things that we've added, we tried it last conference and we're trying it again this time, is our Meet the Speakers networking. One of the, as we talked about to our speakers, one of the casualties of our online conferences is the lack of networking, and we're starting out by trying to do some linkages with our speakers. We have some links. There's a sign-up form underneath the. It's in the description on the YouTube live stream video. There's a link there to connect to to that program. We offered our affiliates first chance to meet with the speakers and opened it up to the rest of the speakers recently. So if you have questions for our speakers, you can put them on. We'll also be gathering those. There's a link underneath the YouTube video in the description to submit questions, but you can also submit them in the chat, and Kara will be sending those over to me. We're starting out with Joe Barke as our technology consultant to set the stage for his work that he's been doing for many years on IoT. Henry Liu is from University of Michigan. He's going to be talking about the work that he's doing on connected vehicles, where we see the connected vehicle as an Internet of Things story, and he'll be talking about the Center for Connected and Automated Transportation and the recently announced autonomous vehicle, connected vehicle corridor between Ann Arbor and Detroit. David Kramer from Ford is going to be. He's the research lead on smart living and the Internet of Things. He'll be talking about, from a more practitioner standpoint, about things that Ford's doing in terms of IoT. We'll take a break around 11 o'clock. Then we'll come back with researchers from the WZB in Berlin Social Science Center, Martin Shavinsky and Gregor Zlakowski, be talking about the research that they're doing on in particular, the Industry 4.0, of which IoT is a part of that. And finally, Trevor White from Toyota Motor in North America is going to be talking about his experiences, work that he's doing, again, more from a practitioner level on IoT within the manufacturing and engineering systems at Toyota. Trevor was the first one he spoke at our conference, I think it was probably 2 or 3 years ago, was the first one to talk about at our conferences about IoT, and we wanted to bring him back to get an update about what's going on at Toyota, and also because it's a much bigger deal now, because we're extending it inside, not just inside the factory, but outside the company. As for terms of post-conference mailings, a link to the presentations and the video will be available probably this weekend. We also send those to our affiliates, but we also get a conference summary that reviews the highlights from the conference. In terms of housekeeping, the agendas, everyone should have received an agenda, but it's also available on our website. Speaker bios, registration list, sponsorship opportunities, affiliate information, upcoming events. That's all on our Future of Automotive IT conference website. We sent that to you yesterday as well as along with the live stream link. And also as I said, the audience questions, the link is underneath the description. It's in the description underneath the YouTube video that's streaming right now. and also we'll be sending you the conference feedback after the conference, asking for your feedback on things that we did right and things that we can do, things that we did wrong. Again, as I said, the links will be available this weekend. I want to also look at another kind of I want to do a little setup for Joe before we start that looks at the how we've been approaching IoT here in Automotive Futures. Now, we've been studying the information technology in the auto industry since the 90s and before the bubble, working in a variety of different perspectives from manufacturers, suppliers, as well as dealerships. So this is something that we've been looking at for a while. But when we look at the Internet of Things, we really see this as part of the evolution of information technology in the automotive industry. It starts for us way back in the 1960s at the GM Tech Center, when a colleague of mine who was working at GM at the time was a mathematician, and he was working at the Tech Center, and one of the executives brought in the first IBM mainframes into the company. He said, "Here it is, do something with it." And of course they did. With some of the programming that went into the original mainframes, especially the things having to do with different models and the links between dealerships and the manufacturers, are programs that they wrote back in the 60s and 70s that were still using in the 1990s, because it's one of those "if it ain't broke, don't fix it" situations. It was only later that things really had to start making some major changes. Of course, the personal computer in the 80s, the introduction of the World Wide Web in the 1990s, and in the late 90s and the early 2000s, really the introduction of different computer programs, modeling and simulation programs in R&D, product lifecycle management programs and product development, enterprise research, resource planning programs in manufacturing, customer relationship programs and distribution, and the story of industry dashboards or company dashboards that were really used by, promoted by the major IT companies, trying to link all these different programs together and to provide dashboards for executives so that they could see instantaneously what was going on in their company locally and also around the world. This was part of the globalization of the automotive industry that we saw really take hold in the 2000s, and IT was a huge part of that. And it would not have even occurred without IT. But sometimes IT, there's a certain amount of promising and under delivering, and also I think companies realized the cost of trying to connect everything together, and it became a big challenge for the companies. So to this day, there's still an issue of all these systems that require organizational systems that provided connectivity and up-to-date data that in the early 2000s was still entered manually into databases. And this is where the Internet of Things starts coming in, because at the Internet of Things, we're not talking about humans they're no longer part of the process. This is after they've done the programming for the machines, for the computers. With the Internet of Things, machines talk to machines, creating an immediate data point that links all the databases and the dashboards and provide immediate and accurate company level information about production, shipments, and sales, and also links companies to their vehicles on the road and their customers who purchase their vehicles. So we look at the Internet of Things from two different perspectives. One before the vehicle is sold, and then the other one after the vehicle is sold. So before the vehicle is sold, most of the things are going on within the company and in the supply chain. After the vehicle is sold, you're working with dealerships and the consumers. So as part of Industry 4.0, the Internet of Things is one of the main technology elements. we're talking about augmented reality, virtual assembly, 360-degree networking, autonomous robots and machines, and basically the smart factory. By incorporating the real world into the digital world, it's possible to create a so-called digital twin that allows real-time display of processes, systems, and the entire production system. So that's something that we look at Industry 4.0. It's supposed to provide higher flexibility, faster response, digital production, the increased efficiency, higher speed. These are issues that were our researchers from Germany and also Toyota will be talking about how these things have actually been working out so far. Because these things that I've just been talking about right now that you see on the screen are things that kind of promises that things can happen within Industry 4.0 using IoT. At the end, you get a more agile supply chain. You have a lot of self-monitoring capabilities. You have a capacity for more customization, a more network flexibility, but you also have more data security and cybersecurity that needs to be done, as well as data management for all the data that is being accumulated. When we look at after the vehicle has been produced, after the vehicle is sold, we're looking at a connected vehicle that focuses on safety, consumer convenience, and autonomy. There's expected a lot of work and money to be spent on this over in the near future, and it's one of the areas where all the manufacturers are looking at. This is work that we have done in terms of safety when we looked at the heavy truck industry and vehicle-to-vehicle and vehicle-to-infrastructure and some of the advantages of these technologies of connected vehicles from a safety standpoint. Your forward collision warnings, emergency braking events, intersection collisions, blind spots, vehicle loss of control, and also from a vehicle-to-infrastructure standpoint, red light violation warnings, work zone warnings, and curb speed warnings. From a mobility and transport environment, especially in terms of heavy trucks, you're looking at weigh in motion, wireless inspections, traffic signal management for fuel efficiency and less congestion, prioritize border crossing, high occupancy, toll lane management. These are just some of the areas that we were looking at when we were doing our studies on these vehicle-to-vehicle, vehicle-to-infrastructure story. But also from the consumer convenience story, the app integration into maps, music, and fueling, autonomous ride hailing, over-the-air updates. Some companies are working on these. Some of them are more advanced than others. And basically OEM links to purchase vehicles for maintenance, and also for the main things that they're looking into the future is cross-selling. In terms of transport systems, we're really looking at support for state and local departments that are able to build roads that can help detect road maintenance needs, traffic usage, and accident statistics, and do this in a more timely fashion than they do right now. Also, weather conditions and predicting traffic accurately. One of the areas that we focused on in our previous conferences, mobility conferences, was mobility as a service, so that you could actually connect different services that you could get you from point A to point B. And this is work that we've been doing since back in 2012. We started with slippery road detection and evaluation, our stuck in traffic research, looking at analyzing real-time traffic capabilities, the connected driver and integrated mobile observations, and evaluating roadway surface rating technologies. This is all the stuff that we've been doing within the last 10 years or so. So when you look at the future of IoT and transportation, you're really looking from a manufacturer's standpoint. The automakers are deploying multiple strategies to remain viable in this space. They're including working with tech startups, partnering with big tech firms, and also building in-house solutions, and also working with their supply base. But when it comes down to it, you end up looking at something like, especially from the consumer side, how much are they willing to pay? And when you look at the different advanced technology categories here from a Deloitte survey that was done fairly recently, and asking how much people are willing to pay for these technologies and for this, we have issues related that it's going to be more difficult to actually make money on this. Now, one of the issues that has to do with kind of anticipating how much people are willing to pay is that some of these services and technologies are not really out there, so people don't maybe understand how much advantage it provides to them. Something like they may not know what autonomy actually is and how it's going to affect them, and what are some of the advantages of it, and infotainment and connectivity. Some of these things are still in their infancy in terms of being produced. So it's pretty early to say, to make a call on this, but these are some of the early research that's coming in on consumers and after the vehicle is sold. So that's my story that I wanted to share with you as kind of a setup for our speakers today. And we'll start off with Joe Barque is going to talk to us about his experience using and working with companies that are working in IoT. Welcome, Joe.
Thank you, Bruce, for inviting me, and thanks everybody for joining us today. So, just a couple of words about what I do. So I am a market analyst, researcher in a number of technology topics. So one of them is the Internet of Things, but I cover other areas in manufacturing, primarily manufacturing. And I also have a specific focus on automotive, in part because I think it's one of the industries that actually has been very active in pushing new technologies, perhaps too often unsuccessfully, but pushing technology to improve development, safety, product lifecycle overall. Also, until recently, I was the first chairman of the SAE, Society of Automotive Engineers, Vehicle IoT Activity. So this is a group trying to understand where does the vehicle fit, the car fit in this global world of IoT. And what I thought I I'll do with you today is actually use the great introduction that Bruce, you gave us in terms of a little bit of history of IT and IoT specifically, but really looking at it from the vehicle perspective. What does it really mean that a vehicle is a thing in the IoT network? And my goal here is to really kind of not necessarily challenge, but really offer a slightly different perspective about how we can, should, perhaps would approach the vehicle in the IoT network. So yes, since long time ago, we are in the era in which everybody and everything is connected. So connectivity is really what's driving our businesses, even our personal lives going forward. So whether it's Industry 4.0 that Bruce mentioned, is it remote monitoring, whether it's equipment monitoring or maybe telematics in a vehicle, over-the-air update that for many in the news, over-the-air update, software update is new, but just primarily because of Tesla. But us in the industry know that we've been aware of the need or the opportunity, both need and opportunity many, many years ago. Long story why we have not done it until Tesla showed us that not only is it useful, but it's almost important to create a brand. But over-the-air update, again, is something that is here, will stay, and it's really one of the fundamental value propositions of the Internet of Things. And it's not only devices, it's also people who are connected, whether it's wearable devices. In many of my talks on IoT, I actually mention even social media, because for me, the Internet of Things is really a collection of all the different sensor points, all the different data discovery points that help us get this best context for better decision making. So to me, people are things too. So everybody and everything is connected nowadays. Not only that, it's the rate in which we connect and utilize the Internet of Things as both technology and a concept is going to accelerate. Whether it's cloud connectivity that will continue to grow, with it all the areas that we need to address when we talk about cloud connectivity, such as security and privacy. With the proliferation of 5G networks, again, we'll see more growth and more activity and more flow through the network, through the cloud network, but also true when it comes to edge devices. So we'll see more and more computing power and decision-making power moving to the edge. You could consider a car as a potential edge device, but also, again, machinery, remote sensor points, they're all going to become remote decision-making properties that perhaps are completely autonomous, or perhaps move some of the decision-making power to the center. And again, it's a topic that I always have kind of an interesting or different perspective about, which is security. Very often when I talk about security in the concept of Internet of Things, my response is, I really do not want to talk about security in this context. Why? Not because it's not important, but rather because I need to be in a point where security and the kind of the affiliated questions about data management and data privacy need to be available as a given, almost a commodity. We need to be at a point where we can connect devices, connect IoT services, enable the digital twin, knowing that through standards and best practices, security is guaranteed. We're not there yet at all, and the risks today are greater than the promise, but we will see great and faster growing improvement in security. So more is going to come in terms of use of Internet of Things. But thinking about it, for us who've been in the industry for a while, IoT under different names is really not new for us. I don't recall exactly when OnStar was introduced. I think it was Rick Wagoner who introduced it around 96. I could be wrong, but it's more than 20 years ago, GM introduced OnStar. And the concept of connected vehicle became a central point in terms of initially product quality and product evolution, product innovation. Eventually, again, it's more of a way to connect with the vehicle, to provide security and roadside assistance services, and again, over-the-air update. But if we take a closer look at the business model, not the technology, the business model, we realize that the Internet of Things or vehicle IoT or the vehicle as a thing under the OnStar thinking is tied to the vehicle. And I'm referring back to some of the slides that Bruce showed earlier. Again, you saw the car in the center of the universe with services around it. So we have now an OnStar equipped vehicle, and it's got to be a GM vehicle, of course, providing content and services and roadside assistance. And if we recall the history, it took many, many years to be able to provide services that the customer will be willing to pay for. So yeah, there's a value, and the OEM, GM got tremendous value from having the connectivity, and it was a good selling point for the vehicle, but it was centered around the vehicle, which means that if you drove another vehicle, you were not able to address or to benefit from the same services. So for a long time, this was just okay or just fine, because again, the services were primarily around the vehicle and you as the consumer in the vehicle. But let me use a different example that makes the point much, much stronger. Some and perhaps most of the value of telematics, as I said earlier, in the vehicle, in the OnStar model, are vehicle specific. They are related to the vehicle. They are VIN specific, vehicle identification number specific. But SiriusXM is a much better example to explain or to observe the business model in which the vehicle is in the center of the universe. So I have a subscription to XM. The truth is I canceled a while ago, but stick with me, stay with me. Let's say I kept my SiriusXM subscription. That really means I benefit from the content from whatever other services, including traffic, for example, traffic conditions being streamed to my vehicle. Now, if I decide to drive my wife's vehicle, in which the head unit is SiriusXM capable, but she does not have a subscription, then I'm no longer able to use the services. So that begs the question, wait a second, who paid for the service? Did my car pay for the service? And therefore, only if I'm in the car I can use it? Or did I pay for it? I paid for the service. Therefore, what I want is the service to go with me, whether I drive my car, of course, my wife's car, whether I borrow your car, whether I rent a car. I paid for a service. I want the service to come with me. And the VIN-centric model does not allow me to do that. So I'll make the point that this model is challenging when it comes to what is the next generation of connected vehicle, what is the next generation of things, vehicles, things in the network. And here's another example that is still evolving, but you must have heard the expression, your car is your wallet, right? So we have services embedded in the car. In this case is Shell gas purchasing services that I can access directly from the car. So I pull into the gas station recognizes my vehicle, they exchange information, and I can just fill the vehicle with gas. By the same way, I can use this service only if I drive a car equipped or subscribing to the service. And what if I borrow somebody else's car? What if I need to refuel my rental car? This model is not available. So I will take a position, and I hope that we can have a conversation about this in the upcoming Q&A and presentation. The VIN-centric model as implemented today is flawed. We still think about an outdated model, which is kind of the GM OnStar model, that everything that we provide is to the vehicle. And no, this is wrong. We provide this to the consumer. Today, it's the passenger. When vehicles become more autonomous, assuming, again, I own a vehicle or I lease a vehicle, autonomous vehicle, it's the occupant. So the occupants want to benefit from services independent of where they are. And in fact, it's the same services that they benefit when they're not in a vehicle. What I want to be able to do is to have a non-stop experience when it comes to content services, including retail services, wherever I am, whatever modality I'm in, and maybe if I'm not driving. But I do not want this service to break just because I'm in somebody else's car. So the future is really this. The current and future is really consumer-centric model, and therefore it's based on the consumer identity. And today, despite what car OEMs would like to see, is the identity is the mobile device. The device represents who I am, what are my services and subscriptions, what is my purchase information, which subscription I just disabled, which one I'm signing to. It represents my most up-to-date information. And when you think about the quality of services, all the way from sheer quality of applications to being up-to-date, cell phones or smart devices, brought-in devices, are so much better than vehicle devices. I still dread, I stopped doing this again, maps update in my older car. It was an experience that nobody wanted to undertake. You put in a DVD and you hope things will work, and then it doesn't work and you call customer service. They say, well, you need to drive for an hour for this to kind of lock in. What? Today's phone update maps on the spot, you don't even know about it. So again, VIN-centric model is wrong, and today the model needs to shift to be consumer-centric, represented by the brought-in device, whether it's a driver or the passenger. So therefore the question is, so where's the value for the OEM? What do we do if the theory of this hypothesis is correct? How do OEM participate in this? Because obviously this is a huge market. How do OEM generate new revenue or at least new value, if not new revenue for themselves, in order to move or to be an active part of this emerging ecosystem? So the competition, as I just said, is not a better head unit, but it's really brought-in devices. Therefore, the competition, when you think about it, when you think about where do I come in and bring value, are not better HMIs. I mean, I appreciate the work there, but investing in better head units. But if all I do, give or take, is mimic my brought-in device onto a larger, better screen, touchscreen and so on, admittedly this is value, better HMI is really not the answer. Voice activation is not the answer either, and I'm aware of some relatively large projects to improve voice recognition in a vehicle. And I'm troubled by that a little bit, because yes, we can get better, but I don't think we can get application in the vehicle to be as good as the brought-in devices, in part because it's a very difficult environment, but in part because other software vendors, whether it's Google or a new startup, investing so much more resources and money in developing voice recognition applications. So I think that investing in individual voice recognition capabilities in a vehicle is not a good use of certainly not attention, let alone budget into the work. So if this is the new world or ecosystem, if the competition is not in those technology-centric activities that some OEMs and the major OEMs are working on, where is again the opportunity? And we really need to think about where's the value in IoT. So stepping back to IoT in general, where do we find value in IoT the way we see IoT moving forward? And I think that the way I'd like to look at it is there are maybe 4 or 5 different levels, not necessarily maturity levels as much as kind of progressions from one step to the other. And these are not stages, so don't look for stages and metrics, but it's a progression in part of technology, in terms of technology, and part of in way of thinking about IoT. So obviously we have connectivity. This is where we deal with device connectivity, security, data management, privacy in some cases. It's the connectivity layer with all the stuff that comes around it. I want to look at this as a commodity. I mentioned this earlier. I don't want to think about connectivity as being any important thing. I want this to be available, almost like a utility. And we are not there yet. We're making huge progress, but we're not there yet. And for that, and I'll make this comment later as well, we need to be much better in common platforms and standards to allow this to be a plug and play, if you will. Once we have connectivity, and when it's a one-off, like OnStar or other services, it's actually easier. We can actually benefit from telematics. So I keep making the point about value overall. We recognize that there's tremendous value for OEMs in telematics. It's monitoring, some cases prediction of failures, and smart OEMs, more kind of forward-looking OEMs, are integrated the learnings, the information, and the findings with the product lifecycle management. Some of them don't do that, but some do. So all the inputs, whether it's failure rates, quality information, quality and reliability, or even customer behavior, whether it's positive or negative, this needs to be fed back into current product and future product development. So that there's value, but it's limited to the OEM. And therefore, it's going to be hard to scale it beyond that. It's going to be hard to ask the consumer to pay for it. And it's going to be hard to use it as the necessary foundation to, again, leverage the growing power of the ecosystem. When it comes to IoT, and again, under some loose definition of IoT, the value comes from the ability to collect, integrate information from different sources. Again, could be vehicle information, could be customer interaction with the head unit information, could be from social media for all I care. So the aggregation and analytics of information. And this will drive better decision. Decision could be made on the spot, road assistance necessary, quality issues impending, or long-term decisions in terms of improving current and product, including current and future products. So it's really moving the organization from being one-off, one connection at a time, to being data-centric, to being driven by data-rich context to make better decisions. And this is where everything opens up, because now we can really drive value from the ecosystem. The whole idea of the Internet of Things is our ability to connect ecosystem partners within my value chain, but also outside of my value chain. I can onboard new content and services, and I can offboard them when my business realities have changed. So the ecosystem where the future of IoT is, but it's also complex because by definition it's multi-domain. We have now to involve or to kind of incorporate connectivity with security and so on, the commodity level, but also data analytics that uses different domains, whether it's consumer and retail domains, whether it's infotainment, whether it's navigation. We have complex domain in data. And it's really, again, networking the partners, because the value of the ecosystem is by its partners, whether, again, it's content, services, navigation, retail, whatever you think you can benefit, you can draw value from having multiple partners. So this is a business platform game comes into play. It's no longer connectivity. It's no longer one vehicle at a time. It's actually having a business platform of which vehicle or all my fleet is part of. So that's the value of IoT. This is the future of IoT. This is where it's heading. So the opportunity is the integration of in-vehicle systems for added value. And again, I'm not ignoring the value of in-vehicle systems because there are opportunities for better, safer HMI, for example. Still, perhaps integration of in-vehicle systems with voice recognition from the broadband device can improve voice recognition quality, which today is kind of mediocre, to a great extent because we understand the acoustics of vehicle better than someone that is brought in. You can think about quality of audio. You can think about perhaps inertial navigation. There are many opportunities that are generated by having a broadened device with these benefits, better user interfaces, better information, up-to-date information with built-in vehicle systems that the device is not aware of and is unable to connect to unless there's a connectivity channel, unless there's standard allow you to do that. And once we have that, we really need to start thinking about partnership for new content and services. And again, I keep coming up with some examples of content and services. These services, by and large, are not going to be vehicles specific. The vehicle need to be recognized. So if I bought gasoline, I need to know who the vehicle is, perhaps, or I want to know that. But it's not the vehicle that buys the gas, but I'm buying the gas through my services expressed by my brought-in device. And the next step we need to drive to is having common platforms, which is large and complex, is difficult politically and business-wise. What I would like to really see us thinking towards is common platforms that allows maybe multiple vehicles within the same OEM connect, maybe multiple OEMs, maybe between an OEM and content providers. And I think that some OEMs are working on, and I am grasping for an example now, but I think that perhaps Google and Toyota, although I could be wrong, talking about a common platform that allows them to do all these things and grow and change as necessary. And one of the key elements of having this concept and having platform is interoperability. So this is a funny picture about interoperability when it comes to EV charging, but I don't mean only physical and interface and connector interoperability, although it would be nice if 21st century we didn't have to worry about connectors and then come with this cottage industry of dongles and so on. What I mean is data interoperability and business interoperability. It's not the charging stations. So we need to develop standards and best practices for data exchange. And it's not only file format, obviously, it is part of it, but it's really about the data content, it's the semantics. Can multiple vehicle exchange data maybe through the back office app, through the application, but exchange useful information while maintaining privacy and security as necessary. And the way to think about it is developing standards and using open source to developing those standards. So that was my kind of suggestion to think differently about the commonly used, the common vehicle-centric model of vehicle IoT. And I'd love to stay in touch and get your thoughts and feedback and comments and suggestions to improve these way of thinking, or perhaps think differently and perhaps adjust it to the way you see the industry. I'm always happy to share my presentation with you. And here's my contact information. And with that, I'll hand it back to you, Bruce. Thank you so much.
Thank you. Thank you, Joe. Thank you, Joe. We'll do a little, let's bring your colleagues here back in so that they can maybe join in on the question and answer session here. And Joe, based on what you were talking about, one of the things that jumped out at me was this the VIN-centric story, and is app integration different from that or similar to that?
Well, app integration, I think, is a way to accomplish a need. I think that in some ways, I'm suggesting that stop thinking about the VIN-centric model is a way of thinking more than specific implementation. But yes, app integration is part of thinking outside of the, well, outside of the tail of the head unit, to use a bad cliche. Yes, it is. But then again, if we focus, if you will, on that, because you could say, well, we have Google Play and we have other apps. The question remains then, are we done that? So I think if we do only that, we perhaps get rid of the unnecessary part of the VIN-centric model, because we want to keep telematics. But then the question is, where's the opportunity for the OEM? So the OEM now is sharing the screen and working hard to develop these integrations. But what is it for the OEM? What's in it for the OEM? And I want to think together and with OEMs about how do we use this to provide yet opportunity for the OEM. So you could use a simple approach like saying, well, we OEMs give you app provider, com provider, captive audience, so therefore we want so many cents of every hour of connectivity. This could be a way of doing it. It's somewhat simplistic, but it's possible. But are there apps that perhaps do not exist today that can be brought in, and once they're integrated in the vehicle and connect to the vehicle system, can add greater value? AC could be one of them, although I admit I'm not a huge fan of AC-centric applications. So I can't get excited over telling the car, Alexa, turn on the AC in my at home. I just can't get overly excited about it. I do it from my phone, but I don't feel the urge of doing this from my car. But again, it's an open question, I admit. I'd like to think together more about what apps can be perhaps brought from the outside, whether the OEMs develop them, but they're mobile device centric or able or others, that when connected to the vehicle, when having location and context where we can add value. So retail is one, again, easy example.
I remember when I was thinking through of the potential opportunities when you look at, and again, this is kind of far out there, where again, this is much more phone based, right? Where the phone knows where you are, the phone knows what your notes are, what your to-do list is. It also knows that it also knows where you're driving, so that it's actually, as you're driving by someplace that's on your to-do list, it could actually remind you, and also cross-sell you to say, you wanted to pick this up. It's actually on sale at this place you're driving by right now. This is intense interaction of the systems. But do you see that as something as a possibility?
Yes, no, I think this is happening, but you're just, I think, providing more examples. How much the phone knows, or how much the phone knows me, and how little the car knows, and how little value the car can add to the phone. And that is it's a challenge for us.
Yes, yeah. David Kramer from Ford, when you hear this story, are there examples that you guys are working on that, I don't want to step all over your presentation, but are there things like this that fit into things that you're talking about and looking at?
Yeah, I think once we get into my presentation, you'll see there's a lot of synergies to what Joe said in the approach that I'm trying to promote at Ford, the customer-centric model, and treating the vehicle as the ultimate IoT wearable.
Yeah. Okay. Yeah, we don't want to step all over your presentation.
I look forward to it.
Joe, one of the things when you start talking about the things that we're looking at in terms of IoT, where do you see us in the progression? Are we in the infancy stage? Are we adolescents? Or I don't think you would say we're mature by any means.
No, we're not mature. I think we are seeing steady progress. I don't think the progress will decline in rates. It's absolutely not a fad or temporary thing. It will continue to in a way, it will accelerate. But I think that we will continue to be kind of disappointed about the difference between our vision and what core technology can provide and industry adoption. In part because we lack standards, or you might say we have too many standards to choose from. In part because we still focus too much on what I would like to call the commodity level. We still focus a lot on security and privacy. And these are important things.
Right.
But every time we talk about connected vehicles, oh, what about the hacking of the Jeep? Yes, we get it. We'll work to improve it. I want to think far beyond that.
Yeah.
And in part because I think, and this is slightly deeper than sometimes what the write-ups or even the analysts are saying, I think we tend to ignore the fact that some industries have natural cadence of adoption. They cannot go any faster. Manufacturing is one of them. In huge part is because equipment does not get refreshed that often. So it's very nice to show a vision of a factory floor with all these instrumented devices and analytics on the floor, and then move it to back office. And this is a time when you throw in, AI, because it's important to say artificial intelligence in any presentation these days.
And you waited all the way until now.
Yeah, it was hard for me to do that. But think about factory equipment. If it's the kind of brownfield, and automotive is actually in the forefront because of the automation of robotics. But think about more traditional manufacturing. Some of the equipment is old. Some of the manufacturing equipment in the US is about 30 years old. But if it's a 30-year-old Cincinnati Millicron CNC machine, it's perfectly okay. And I don't have the budget, certainly don't have the time to take it offline to instrument it. So the industry moves in the cadence in which it can move. And so they're going to be, we'll continue to see islands of success in IoT because they will all demonstrate great success. But proliferation in brownfield factories is going to be slow. So we will continue to be, frustrated by the rate in which the industry can adopt new technologies.
Yeah, I think that'll be part of Martin and Gregor's presentation as well about Industry 4.0 and how it's playing out inside factories. And I think there's some overlap about what you're talking about.
How do you see the competences of the American, European car manufacturers to move into this IoT field you described? Because it's not just a question of standards of technology, but also of internal competences, the skill base. And I see how companies struggle with it here in Europe. So what's the situation in the US?
So it's an interesting question, and I'll get in trouble, but I'm going to go there anyway. So yes, I think the question comes up about talent and skill and experience. To a huge extent, I think that we lack more at the other end of the stack. So yes, there are questions about, again, connectivity and privacy, about instrumentation, data analytics, prediction to some extent, but these are still kind of the lower end of the technology stack. I think we need to grow in maturity when it comes to the value of IoT. How do we move very quickly from connectivity and data to data aggregation, analytics, and decision-making? And here, there is a difference between Europe and the US, and I think it's fundamentally the difference between how we think about how these things are moving forward. I think that Europe is, I'll say ahead, but I don't really mean ahead in this simple sense of it, because the Industry 4.0 is kind of part of an overall initiative. So there was an initiative with guidelines and standards and budgets, and it goes down to university training. There's more like long-term, somewhat planned activity. I'm sure it's not perfect, but it's somewhat guided. Whereas here, it's more a matter of Silicon Valley mentality. We're going to connect it, see what happens. We have, we'll drive autonomous cars on the streets. If someone gets killed, well, sorry, that's the way it is. But it's interesting that when I have these conversations, every side envies the other one. So the Europeans envy Silicon Valley mentality in terms of access to cash. You have a good idea or you have not such a good idea, you can probably get funding for it. So Europeans would like to have that one. Conversely, here we'd like to have some guidance, because if we go back to some of the points we were discussing earlier, if we want to get to the stage in which we have platforms and common standards and best practices and interoperability, we have to have kind of multi-country, multi-domain, multi-industries collaboration, which is not happening in the US.
Very good. Thank you, Joe. One of the things that you mentioned in your presentation and in the Q&A here is the cost issue. When you start looking at cost of IoT, what do you see as the major cost involved? And I think you've talked about some of the financial rewards, but I think it's one of the cost issues I think might be holding back companies in terms of this.
Yes, no, I agree. Cost is always a problem. And it seems to be one of the issues that when you look at surveys about why or what holds project back, budget is often the issue. Yes, if you think about the need to, again, take a brownfield, even greenfield approach to manufacturing and implement Industry 4.0 project, then of course the cost of instrumentation, connectivity, security is a factor. And here again, when we get to the point when we have this available as a commodity, it will no longer be a problem. Parenthetically here, by the way, there are some other trends that perhaps will kind of weigh down on the proliferation of Industry 4.0, which is initiatives in Russia and in China to have their own internet. So if we do that, a lot of the power of the internet that we used to drive Industry 4.0 will go away. But that's maybe a side comment. So yes, but we are not in the point where we have platform that we can plug and play and benefit from this. So for projects, when we look at for proof of concept and project, when we look at the payback, we often find a problem in the cost itself and in the time to positive cash flow. So no one, I don't think, doubts the value of IoT. I don't think we have naysayers as far as, there's no value. We'll never be able to go positive. But if we have a project that says, there was a recent BCG, Boston Consulting Group, and PTC study that says ROI, pardon me, ROI in 3 years. And I asked, I don't know if 3 years is good. Is it fast enough? Is it disappointing? I don't know if it's good. But I know that some projects will never see the light of day if the ROI is 3 years. I hear about project responses. Well, if it's more than 18 months, then I'm not interested. So let me take the opportunity and offer a different approach altogether. If we agree that IoT is fundamental strategic value to the organization, if we agree there needs to be a platform upon which we build new value, then we should really take a different approach to payback. We should borrow from real options in economics, which says, I invest in something for future investments, so I invest in some instruments, and I'm not expecting to see value from them, but I expect those to enable new investments. So if we agree that the basic IoT implementation, maybe the proof of concept, maybe initial implementation, a small one, is foundational, we don't need to justify its investments. So the CFO need to approve that. Now, once we have the foundation, we can prove the value of new product, of new initiative, and then we can actually measure the ROI and say the ROI will be such and such. If this is too abstract, I have an overly simplistic example. We still use fax machines, God knows why, but we use fax machines. So if you go to your manager and say, I need to buy a fax machine, she will never ask you, what is the payback on this fax machine? Why? Because she says it's foundational to generate new business. So why don't we think about the infrastructure of IoT as such? It's strategic investment towards future growth. And therefore, I don't need to worry too much about payback. I think it's it's a way of thinking more than, here's the prescription.
Very good. Yeah. Thank you very much, Joe. One of the people online was sent in a question about who do you think should make revenue from the consumer-centric model? The OEM, the smartphone applications, the dealers? How does this revenue get distributed?
I guess it depends on application, where, who provides the value, right? Mm-hmm. I don't think I can answer this directly.
Yeah.
So who delivers? And actually, I'm glad that the question included the dealers. So what is the role of the dealers? Where do dealers amplify their value, which today challenged, providing some value? So is it the car emailing you its monthly status? Is it better scheduling? It's a struggling, not struggling, but it's a business that needs to find more ways to demonstrate their value, because dealers they need to be in the equation for the foreseeable future.
Last question for you. We can't talk about anything nowadays without talking about the effects of the pandemic. And in terms of from what you're seeing in terms of companies and IoT, is the pandemic setting things back? Is it accelerating, or pretty much staying stable?
Well, what the pandemic did is expose the weaknesses in our supply chain and product value chain. For years, for decades, since after the Second World War, we were working on leaning our supply chain. So we squeezed whatever we could out of the supply chain. And more recently, we started accelerating kind of overclocking development cycles. We borrowed from agile development. So we really squeezed everything, we could from the supply chain. So, and we were pretty good in doing that. So agile and lean and just in time and everything that Toyota was pushing since after the war, and we all adopted it, was very successful. But what we neglected to see and to respond to is the impact of those decisions downstream. So yes, lean process, but we break the process, or then we create a very brittle process downstream. So the pandemic really exposed those. But in all fairness, it's not the first crisis that we were exposed to. We talked about the pandemic today, but the earthquake and tsunami in Japan happened, in 2011, 9 years ago. And what happened then? We forgot how the industry, came down to its knees because, again, of overly brittle supply chain. So hopefully we'll be better in learning and responding. And yes, organizations are responding to it, in part because it's yet another magnifying glass into the risk in overly optimized processes, and in part because it gives an opportunity to say, see, we have to do something. We have to improve visibility to supply chain, to inventory. We have to have better ability to source new suppliers and so on. So the statement of the day is don't ever let a good crisis go to waste. And I keep discovering more and more claims to who said it first, from Churchill to someone said this yesterday, I forget what it was, but I was and Rahm Emanuel, the mayor of Chicago. And funny thing, I found an article that says the philosopher Rahm Emanuel, meaning philosopher Immanuel Kant. But so you see so I was very curious about it. I could not find a reliable source. But what is very obvious, it's a very Machiavellian politics thinking. And forget Machiavellian kind of hidden agenda. The idea is it's opportunity, it's a crisis. We have to think differently, and let's get our energy and thinking of our crisis solving mentality to find better solutions that will last long term, and we will learn from the mistakes and will not forget 10 years from now what happened.
Yeah, very good. Thank you, Joe. Let's move on to our next speaker, Henry Liu from the University of Michigan. Henry has put together the Center for Connected and Automated Transportation, as you can see on the screen here, and he's going to be talking about the connected vehicle as part of the Internet of Things. Henry, take it away.
Thank you, Bruce, for the invitation. It's a pleasure to be here. What I'm going to talk about today is to talk about connected and automated transportation research at my own lab. And then, as Joe mentioned, I'm a professor in the Department of Civil and Environmental Engineering at the University of Michigan. I also direct the Center for Connected Automated Transportation. The Center for Connected Automated Transportation is a US DOT funded research center. This is a regional center, Federal Region 5. US DOT has about 30 centers around the country, and then 10 of these centers are regional centers, and the center I direct is a regional center. And this is also a consortium of universities, and that include obviously University of Michigan, Purdue, and then Illinois, and University of Akron, and Central State, as well as Western Community College. So we are a designated center by US DOT on connected automated vehicles research. Let me Somehow my slide doesn't move. Okay. So what I'm going to talk about is I'm going to talk about two projects I'm working on. These are the two research projects. And then I'm going to talk about Connected Corridor project just announced a couple of weeks ago. And one of the project I'm going to talk about is what I call OSAS, is optimizing traffic signals as a service. This is a traffic signal optimization system utilizing connected vehicles as mobile sensors instead of utilizing infrastructure-based sensors. This one utilizes connected vehicle trajectory data to optimize traffic signals. And the second research project I'm going to talk about is to build a naturalistic and adversarial driving environment for connected automated vehicle testing. And in that, I'm going to talk about how we generate testing scenarios and then how we're going to utilize augmented reality to test connected automated vehicles. So these two are the research project I'm going to discuss in this presentation. And then, as I mentioned, I'm going to talk about Michigan Connected Corridor project. Just sort of an introduction in terms of what are the traffic signals. And we know, almost everyone knows traffic signals. These traffic lights is, you can see it in many of the cities. And in the US, there are roughly around 300,000 to 400,000 traffic lights. And each of the intersections, you will see a box at the intersection. These are traffic signal controller cabinet, and within the cabinet there's a controller. And in the US there are 5-6 major controller vendors: Econlight, Siemens, McCain, and such. And in many of these intersections, there are also vehicle detectors. These are the detectors to detect the traffic flow, and then traffic controllers will assign green time according to the traffic flow rate. And there are many different type of control detectors: loop detectors, video detectors, radar detectors, and so on. So and one of the things you will see, although we've seen traffic light is everywhere, but this is a traffic signal report card in 2012 conducted by US DOT, and to look at in the US among these 300,000 traffic lights, what are the performance and what we do with these traffic lights. And so you can see in terms of our overall management of the traffic light, the grade is D+, so it's not a very good grade. And particularly if you look into the specific category of traffic data and traffic monitoring and data collection, the grade is F, meaning that we don't really collect and archive and utilize traffic signal data efficiently. In fact, we don't even collect data from these traffic lights. So it has been a issue for a long time, and the reason for that is most of the traffic light, about maybe more than half of the traffic light, doesn't really have any detector. So there's no data really coming out of these traffic lights other than just signal phase switching on and off in terms of green light and yellow light and red light and so on. But even for those traffic lights does have detectors, and these detectors are prone to errors. And for example, in Michigan, because it's the winter, sometimes snow plows and then damage these detectors buried underneath of the pavement. And so these detectors oftentimes need to be maintained and repaired during the summer. And then if we cannot keep up with these maintenance, then this detector doesn't really work. So at any moment of time, that's probably has a large percentage of these detectors doesn't really work. So we don't have data coming out of these detectors, even we have it installed on the roadway. So so that's also why in terms of how we optimize these traffic signal systems, and although the benefit cost ratio for signal optimization is 40:1, which is very, very high, but usually these traffic signals are only retimed every 2 to 5 years. So oftentimes these the signal parameters that the control parameters that operate these traffic signals oftentimes is already out of date because of the traffic flow changes. And the reason for that is because we don't have very good data, as I just mentioned. And then in the current practice of traffic signal optimization, we manually collect the data, and then we get performance measures and utilize these performance measures. We can optimize these traffic lights, and then we implement and then evaluate. So the whole process is fairly time consuming and also costly. And so every traffic light optimization is roughly around $4,000 to $5,000 just for one single intersection. So consider we have 300 and 400,000 in these traffic lights. So even one-time optimization is very costly. So the solution for us is we utilize, instead of these infrastructure-based sensors, we utilize mobile sensors to evaluate the traffic signal performance and then to optimize these traffic signals. And so the previous speaker has already mentioned OnStar and others. I would say most of the new cars right now on the roadway in the last few years are connected vehicles. These vehicles has telematics inside, and then they can actually collect these the vehicle trajectory data from these vehicles. So utilize these type of data, we can actually evaluate traffic light performance instead of rely upon these infrastructure-based sensors. Just think about these, these vehicles. Essentially, they are connecting to a backend server. When they stop, we know they are stopping, and then so these are the things we care, and then to utilize these as prop vehicles in the traffic flow, so we can actually get performance measures from these vehicles, and then to evaluate the traffic flow performance, and then with that we can evaluate delays, number of stops, queue lengths, even sometimes oversaturation of traffic flow. And then with the performance measures, we'll be able to optimize these traffic lights, and then we implement. And since these data are continuous data flow, so we can actually change this previous, the current state of the practice, open loop type of system into a closed loop optimization as a service. And this is much faster, iterative. It's not limited in the scope because we have data in many different cities and places. So our solution, really, the key of these is to evaluate these traffic signal performance and to estimate the traffic state with connected and automated vehicle, connected vehicle trajectories. And so, so the reason we can do that is because vehicle trajectories from these connected vehicles contains very good traffic flow information. Just to give you a sense, if your vehicle, one of the vehicles stopped at before a red light about 100 feet to the stop bar, then we know about roughly about 4 vehicles actually in the queue. So that 4 vehicles, these are the information related with stopped vehicles. And if we observe many of these connected vehicle trajectories, we can essentially evaluate the performance measures of these traffic signals. And then once we be able to evaluate, then we know how to adjust these traffic lights to respond to traffic flow conditions. And also, I want to say the reason we can offer this as a service because we do not rely upon infrastructure-based sensors. We rely upon these mobile sensors. So all of the data is being offered on the can be collected on and stored at the cloud, and then we can all the computation is carried out on the cloud as well. We just basically send the optimized parameters to the transportation agencies' private network, and then to the traffic control center. and then the control center will implement these into each of the traffic light, and then to change the traffic signal parameter. So as you can see, everything in terms of data collection as well as computations all occurs on the cloud, and then we can just provide the optimized parameters to the traffic control system. So that's why we can offer this as a service to the transportation agencies. This actually has been implemented, in fact, between 2017 and 2019, I took a leave of absence from University of Michigan, and I was chief scientist at Didi China. Didi is a mobility service provider, and it's, if you don't know Didi, essentially these are Uber China, and they acquired Uber China some time ago, and they are one of the largest mobility service providers in the world. During the 2 years I was in China, and so I started a business unit called the Smart Urban Transportation Business Unit under Didi. And then one of the products of this business unit is to develop the OSAT system for the cities in China. So this is our implementation in the city of Liuzhou. It's one of the cities in Guangxi province, and then utilize the mobility service vehicles. And so for the mobility service vehicles, the driver's cell phone actually connected to the backend server in Didi, and then every 3 seconds these vehicles report back in terms of their locations and speed and information like that. And we utilize that information as mobile sensor to measure the traffic flow performance in the network, and then to utilize that information to optimize traffic signal. And so we implement this actually in May of 2018, and right now it's still in operation. And so we just want to show you a video of this implementation. So the left-hand side is before, the right-hand side is after, and these areas of green box, these are the two CBD areas. One is the old CBD area, and the other one is the new CBD area. If you compare the two before and after, you can see that after we implement our system, and you can see there's much less red dot and much more green dot. Green dot means these are all, by the way, all of these dots are vehicles, are DD vehicles, and the green dot means faster speed vehicles, and the red dot means slower speed vehicles. So you can see the traffic flow get a lot better after we implement the OSAT system in Liuzhou. And then just during that period of time, if we look at in terms of the average delay per vehicle per intersection, and it's reduced by about 9%. And then in terms of average number of stops, it's reduced by 6%. And I should mention the implementation, as I mentioned, is offered as a service. We don't need to we don't need to instrument any new sensors on the roadway. This is just utilizing the byproduct coming from the mobility service providers, and utilize this as a mobile sensor to optimize traffic lights. And so I came back from China last year's fall, and so right now I'm working on OSAT's implementation in the US. So that's the first project. The second project I'm going to talk about in this presentation is autonomous vehicle testing and evaluation. And this is actually quite difficult topic, and the reason for that is most autonomous vehicles usually is artificial intelligence based machine learning algorithm, and so that limit the use of the traditional logic based verification method. And so in the practice, usually we utilize the agent environment testing framework. However, this framework usually have two major challenges. One is the high dimensionality, And as you can see, when these vehicles, autonomous vehicles running on the roadways, there's many different factors affecting these autonomous vehicle, that including the static parameters like number of lanes, weather conditions, and things like that, and then dynamic factors like other roadway users. So the dimensionality of this driving environment is very high. The other thing related with the difficulty of the AV testing is that the event we are concerning is usually these are crash events, and these are small probability events. So these rare event itself is difficult to model it. And so if you look into the autonomous vehicle testing, so this is really a multidisciplinary problem. It's concerns with automotive engineering, concerns artificial intelligence, also concerns in terms of with transportation engineering. So we have to model the environment better. So so to test these autonomous vehicles, usually we apply a scenario generation type of method. So we will need to generate scenario testing scenarios. The way we generate scenarios is we start with data collections. That's why you see all these autonomous vehicle developers and running these autonomous vehicles on the roadways. They are essentially collecting data and then processing this data to look at what are the challenging scenarios for autonomous vehicles, and then they can select these scenarios and then replay this in the simulated world and then conduct the simulation testing. And if you look into the problem with this practice is, one is even you have many autonomous vehicles running around to collect the data, the scenarios you can collect is still limited. And also in this type of testing, there's no interactions between your simulated vehicle with the background vehicle, because the data coming out of these background vehicles are already collected. So the way we propose is to establish naturalistic and adversarial driving environment. So we want to have a naturalistic driving environment for these autonomous vehicles. At the same time, we want to challenge these autonomous vehicles as well. So the scenario selection portion we will replace by naturalistic driving environment modeling, and also naturalistic and adversarial driving environment modeling. So these are the two different steps, and obviously the NADE is based upon the NDE step. So the way we generate scenarios is, if you consider all these scenarios is a scenario space X, and all of these big black dots are the scenarios you somehow the vehicle will experience, because the dimensionality of the scenario space, the number of scenarios is just too big to do the brute force type of experiment. So we have to select a small subset of scenarios to conduct a test. The way we select these subset of scenarios is to rely upon a measure we call the criticality measure. So what are the criticality measures we have to utilize? And we want the scenario to be naturalistic, meaning it could occur in the real world. And then also being adversarial, because we want to challenge these autonomous vehicles. So the criticality measures we have developed have two components. One is to look at the manual challenge of a scenario, and then another one is to look at the exposure frequency of the scenario. And then we multiply these together and to calculate the scenario criticality, and then to select these high criticality scenarios to test the autonomous vehicle. And all of these are, if you have an interest, these are in the recent paper which is published in IEEE transaction. So once we generate a scenario, we want to test these scenarios not only in the simulated world, but also in the test track. And the test track we utilize in our case is to utilize the MCD facility. which just were just besides the University of Michigan's Transportation Research Institute. And one of the limitation of this type of test track are empty test track. We have all sorts of infrastructures within the test track. However, there's not enough background traffic. So the way we do it to overcome this issue is to build a simulated world running in parallel with the test facility. And then all these simulated vehicles, their position and speed information will be coded into basic safety message, and then will be sent it to the roadside unit to broadcast. So for testing vehicles, they will receive these background vehicle information, so they can actually interact with background vehicles and test out different type of scenarios. And I should also mention the control system in the simulated world and in MCity are completely synced. And so that we can reflect whatever happens in the real world also reflect in the simulation. So in this way, we can actually generate testing scenarios and then implement these scenarios in the test facility, and then test your automated vehicles in the test track. So I'm just going to show you, this is a video. Before I start the video, I want to tell you that the right-hand side, this is the simulation, and then this small corner shows you MCD test facility. And then this is a very simple scenario, which is a cut-in scenario. So you will see two vehicles on the stretch of sort of freeway within MCity, and then the following vehicle is a real Alpha autonomous vehicle, and then the red vehicle is the cut-in vehicle, the background vehicle cut-in. And so, so on your left side, the bottom left, these two curves, one is the range between the spacing between these two vehicles, and then the other one is the relative speed between these two vehicles. And so just to show you the video, one is a number of scenarios being tested, and this is the non-crash scenario. So you can see this is the automated vehicle, and this vehicle perform a cut-in, and then you can see there's still distance in between, so you don't, so there's no crash. But these scenarios are generated by utilizing the scenario generation method we just talked about. So this is a near crash scenario. So these two vehicles getting very close to each other. And the third scenario is a crash scenario. So the relative space become negative. So these two vehicles bump into each other. So that's how we implement the test in MCD facility. This is what I just showed you is actually just a very simple scenario. We can generate these scenario continuously in a city, and this is another video in a simulated city to generate these scenarios. You can see these are this is autonomous vehicle, the blue car, and the green cars are essentially the background vehicles. We can. The last portion I was left over, I think it's on the Michigan Connected Corridor project, which was announced a few weeks ago. And the vision for this project is intended really to create lanes that will be purposely built to accelerate and enhance the connected automated vehicle deployment. And this project is intended to be future-proof. And it might start with, it will start with shuttles and vans, and then the shared mobility vehicles, and then later on will be expanded to other connected automated vehicles, such as personal vehicles and also commercial trucks. The project is actually led by this new company called Cavenue, which is a subsidiary of Sidewalk Infrastructure Partners. Sidewalk Infrastructure Partner is a subsidiary of Alphabet, And Cavenue was selected by MDOT to serve as the master developer for the first phase of this corridor project. And the first phase of this project is really the design of this corridor. And there's a group of OEMs are also involved with this project, Ford, GM, Argo AI, and others. And the U of M is the academic partner, so I'm also involved in the first phase of this project. So this is the indicative potential route. It's not, and nothing is set in stone yet, but you can see this is connection between Detroit, the Central Station, the Corktown location to Ann Arbor, and both Michigan 12 as well as I-94 will be utilized as potential routes. And then in the first phase of this project, Cavenue will be working with the stakeholders along this corridor to develop a plan for the Connecticut Corridor project. And as you can see, this is the probably most economically vibrant locations in Michigan, and there's many companies and academics and universities, stakeholders, and many cities are also being involved. So this is in the first phase of the project. We'll discuss how this project will serve their needs and transportation goals. This project is really focusing on building infrastructure for the deployment of connected automated vehicles, as we have seen even with $80 billion of investment for so far in the last 10 years for the connected automated vehicle deployment, the development. The fully autonomous vehicles is probably still years away in terms of large deployment. And so this project is intended to build a demonstration for infrastructure deployment so that we can accelerate this connected automated vehicles. And so the infrastructure is really contains both physical infrastructure as well as digital infrastructure. And on your left-hand side, the picture shows you sort of like a freeway scenarios. You can see there's dedicated lanes for connected automated vehicles. And then in terms of the infrastructure, not only we need to have well-maintained roadways, but also clear machine-readable markings, traffic signage, as well as digital infrastructures like connectivity, high definition maps, and so on. On your right-hand side, this shows you urban scenarios with this connected on the connected corridor. You will see these adaptive signals and then supporting infrastructures with chargers, wireless charging stations, and then the dedicated lanes for connected automated vehicles, ride sharing vehicles, as well as the smart curbs, so that these vehicles can be utilized to pick up passengers easily. So those are the infrastructure being envisioned, and they will be discussed in the first phase of the project. And the first phase of this project will be 2 years, so starting from August this year to 2022 to complete this project for the design of this project. And as I mentioned, Sidewalk Infrastructure and Cavenue are leading this project, and they are the master developers selected by MDOT to lead this effort. And so that's my last slide, and this is my contact information. And so if you have questions and comments, feel free to contact me. Bruce, back to you.
Nope. Okay, thank you very much, Henry. As we said in our in the agenda, David's work He's the research lead for smart living and Internet of Things. And so been with Ford for, I think David said 8 years now. So David, take it away.
Sure. Am I sharing my screen?
You are.
Great. So thanks, Bruce. As Bruce mentioned, I work for Ford in a group that I like to call Smart Living. I'll talk to you a little bit about what that means. But first, I will go a little bit into what Ford's vision is, or at least was announced 3 years ago in a shareholder report, the role that we play within the company, and then some of the definitions of what I mean when I say smart living, and what we see as the enablers to IoT, some of the challenges that this concept proposes. So you'll see a lot of synergies with some of the things that have already been said. An approach that we've taken and we think is been working out good for us, and then some give you some glimpses into the future of what could be as a result of this paradigm of IoT. So stepping back a little bit into the past, at the Consumer Electronics Show, we were the keynote speaker back in, I think it was 2018. And the topic there was bringing back the streets to the people. And also around that time, 5 key principles were laid out in our annual report. And if you go through these 5 key principles, you can quickly see that IoT is essential at enabling each of those. So the first one, prepare for disruption and becoming fit. You know, a lot of times when you talk about large corporations and becoming fit, your first mindset is to that of letting people go, but that's not really what that means. It's more about putting the calories in the right places, the resources where they need to go to get the most value for the resources that you have. And with Industry 4.0, which we'll hear a little bit more about later today, IoT helps enable a lot of that fitness within the company. And we'll talk a little bit more about some of the fitness and how COVID has helped push that along as well. Ford is always going to be a vehicle business and in the business of moving people and goods, but our vehicles are going to be smart and connected. And again, we'll talk a little bit about what smart is and of course the value of connected, but again, IoT, it's all about connecting. And then as our previous speaker was talking about, there's the need for the transportation operating system. So we're going to get into the whole ecosystem that was also talked about a little bit earlier today that's needed surrounding the whole vehicle aspects of IoT. And then IoT is both great for being disrupted, but also to disrupt. And so there's a lot of opportunities once IoT is fully realized that we can generate new revenue streams beyond the current core business. And so if we imagine this world of tomorrow, IoT is the core enabler at the base of this. And we'll talk a little bit, like was mentioned earlier, we've been doing IoT in a sense for a long time, but really what has changed? Why is this term being used these days versus what we've been doing in the past? And we'll talk a little more about that. So let's get into what is smart living. So I tried to brand my team, even though we're focused on IoT, we're part of a group that focuses on emerging technology in general and how do we apply that emerging technology across Ford. So it's not just the vehicle, but the entire enterprise. My core focus is on the Internet of Things, but I wanted to step up to a higher level and talk about how IoT within Ford, the context of Ford, can be used in different ways, not just in IoT as itself, but all the other emerging technologies that tie into it as well. So things like artificial intelligence, that's great. We're exploring IoT, but we're also generating tons of new data now. And so how do we use that data in new and novel ways with things like artificial intelligence? How do we use augmented reality and virtual reality to enhance the experience for the users once we have this concept of IoT in place? So that's why I've branded it a little bit higher level than Internet of Things. We do have a lab that we operate out of, so we have a little maker space, and so we can develop some of our own in-house technologies. We take other technologies outside of Ford and look at them and evaluate them, sometimes reverse engineer them. We work with universities and consultancies and so forth to get all these inputs in to understand where this technology is going and what is the benefit, financial benefit for Ford, because we are a business, and I always say IoT is great, but we should only do IoT where it makes business sense and business value, which we'll talk a little bit about more. And then we also like to look out in the future and see where things are going so that we have a roadmap and a path that we want to get to. The future's not set, so we want to be able to be prepared for disruption, but also be able to promote the kind of future that we think is most advantageous for humanity. And so with our approach, you know, being an automotive company, everyone thinks, well, the first thing you're going to look at is vehicles. And I'm like, no, that's not where I want to go first. I look at it from the standpoint of people, places, products, and processes. So my first approach was, well, what are we? We have 200,000 employees at Ford, and what are the challenges that we're faced with in terms of mobility and all the concepts around that, and how can we use IoT to improve life for the employees? And so it just happened that perfect storm when I came to Ford. All this, everything was happening where the industry is changing, the concept of mobility is strengthening, and we decided to change up our campus and rebuild some of our buildings and create new state-of-the-art facilities. Well, that's what a perfect place to explore how IoT and can benefit the human by how people use those spaces. And so initially started working with Fordland, who owns all of the wholly owned subsidiary of Ford, who owns all of our properties and that we operate out of, but also leases commercial properties to non-Ford entities. So they're very interested in making their buildings more efficient and more usable for the occupants as well. And so we started working with them and trying to introduce some of the concepts of IoT and how that could benefit them in terms of energy management, occupancy, and so forth. And I'll go into some examples as I describe what smart means by using a building as an example. So once we understand how people operate in buildings and move from space to space, whether it's home or entertainment venues and so forth, we start to get an idea of how IoT can start benefiting the customer, which then can help drive what is it we need in our product. And so, as I mentioned earlier, I see the vehicle as the ultimate IoT wearable. And how do we make that wearable smarter and more capable of providing value to the customer? That in turn is going to tell us what it is we need to manufacture. And once we know what we're manufacturing, it determines how we need to manufacture. And so then again, we start to incorporate IoT principles into our manufacturing space and evolve that. And then the whole world is just changed from underneath us, and it becomes a cyclical process again of, okay, now what do we need to make life better for the people, and go through that whole process again of improving. But it always starts with the people. And so let's talk a little bit about what I mean when I say smart. So you hear that term often, smartphone, smart TV, smart home, smart car. What is really making that device, that object smart? Is it all of the technology that's built into it? You know, the sensing capabilities, the accelerometers, the video capabilities, the camera capabilities. What really drives that definition of this is now a smart device? When did a phone suddenly become a smart device? Well, if you think about it in terms of technology, I guess you could say it's smarter, but really, I used to use this example quite often in live presentations where I'd ask Siri to turn on the flashlight and Siri would respond, sorry, I'm not able to do that. I guess Apple's seen my presentation and they fixed that. But one night when I was getting up in the dark, I needed some light and I asked Siri to turn the flashlight on. She responded with, "Sorry, I'm not able to do that," just as I stubbed my toe on some furniture in the dark. So here I have this phone with all this amazing technology, but the resident personal assistant inside that phone could not even turn on the resident flashlight in the phone. So to me, that phone at that moment wasn't very smart. So it didn't solve my problem. So in terms of what I mean when I say smart, it's all about solving problems for people and making life easier and relieving them of some of the burdens they face, whether it's a cognitive burden or a physical burden, and giving them new ways in operating so that they can go on and do other things and seek out other opportunities. So a definition of what smart is, that was what smart was not. I'm sure you've all gone into a parts store looking for a part, especially light bulbs, and which light is for your car, and can vouch for the fact that that's a difficult task. And so there's a lot of opportunity and capabilities that we could do to make a simple process like that a lot smarter as well. And we could start with the car and enable capabilities within the car to communicate with the parts store and all that stuff. But before we even get into that, where we're changing up products, we have the opportunity to do minimal viable products. And so one of the things that I like to focus on is the fact we have a conference room. So why don't we use that as a vehicle? And you might say, well, how is the conference room the same as a vehicle? Well, in the future of autonomous vehicles, what is a vehicle at that point? It's a 55-mile-an-hour conference room. So in that context, we're able to use other paradigms to do research into the art of the possible of solving people problems and making life or technology smarter for them. So for an example of a conference room, let's say I go into a conference room and suddenly the conference room says back to me, "David, I see you're in this room. There's a meeting that's scheduled in this room in the next 15 minutes. Could I find a meeting for you?" And I respond, "Yes, please." And the room says, "Okay, David, please step out in the hallway, follow the blue flashing light." As I step out in the hallway, there's a light that's flashing for me, so it guides me through the hallway. And as I'm walking through the hallway, I hear through directed sound, "David, I see from your calendar you've been meeting with Bruce, and there's some unfinished business. Would you like me to invite him to the conference room I'm taking you to?" And I say yes. And so suddenly, Bruce and we end up at the same conference room at the same time. All of this taking place behind the scenes because the room has enough sensing capability and technology in it to understand what my needs are. And instead of me asking the room for services, now the room is providing services back to me. And so that's a future that I can foresee that IoT can bring to us. And once we can get that working in personal spaces, it's only another step forward to then put it into the vehicle space. Some of that may scare some people. A room, an inanimate object, having the knowledge of who I am and what I'm doing, and controlling my movements through a facility, for example. But then, could we incorporate other technologies such as blockchain to mimic selective amnesia, so that once you're done using that room or that service that the room is providing, it forgets everything that happened and your ledger is protected until it's used again, and then it builds off that ledger and becomes aware of you more and more over time in a protected manner, so that it can offer better and improved services over time. So when I think of vehicles, similar to what Joe had said, that the vehicle is a thing, I also think it's a thing. I think it's the ultimate IoT wearable device. So when I consider getting into my vehicle, I think of it as I'm putting that vehicle on me, and even though it's moving me about, I'm really wearing it. And inside that vehicle, I have a bunch of sensing capabilities and technologies that I could use to my advantage. It's similar to the watch. At some point, the watch started to get smarter. We went from mechanical systems to quartz to, in the 80s, there were calculator watches and alarm watches, and to the present, where now watches are connected to an entire ecosystem. You know, back in the past, prior to the smartwatch, the watch could do a lot of different features beyond telling time. But once that watch became connected to other things like your shoes or your refrigerator and other devices in your home, now that watch has expanded into many different types of capabilities and functionality. So when I look at the vehicle, I look at, well, what is the things around the vehicle that we can exploit and create this ecosystem and work on those things, because the vehicles themselves, they're already getting smarter, just like the watch got smarter over time. But the world needs to keep up with that too and provide that ecosystem around that device. And so when I look at IoT, both inside of a company and outside of the company, I see it a lot more of a people problem than it is a technology problem. So if you envision the analogy of dogs pulling a sled, early on, all the dogs were going in a different direction. This concept of IoT, everybody's going off and building their own things and trying to create new technologies and conveniences, and none of it was compatible with the other thing, and so it was a lot of chaos. Well, we've gotten a little more aligned. You see in the upper right corner, you've got some of the dogs going in the same direction, so you're going to be able to pull that sled a little easier. Some dogs are still facing away, so they're going to provide the resistance. And then you've got that dog who's on top of the sled, which could mean two different things. They're either going along for the ride, which is got a whole host of analogies there, or they're weighing the sled down. But ultimately, where we need to get is all the dogs aligning in the right direction. And that's when we can get the true value of IoT globally and create enormous growth for everyone. So within Ford, obviously connectivity is crucial to us from the vehicle standpoint, and you've probably heard of a lot of initiatives that have been released in the press, but it's also vital to us in whatever we do with IoT, whether it's in the factory, whether it's in the buildings, or even the people, as we get into some of the COVID type applications. Within IoT, I always stress there's three fundamental things that we need to consider, and that is connectivity has to be available everywhere. So when you think of IoT, and I'll talk about this at the end, Internet of Things, those three words, Internet of Things. Internet is all about the connectivity. We've been doing this for a few decades now. What is really changed in the connectivity piece of it is, what are we connecting? Now the thing can actually become so small that the connector to that thing is not feasible anymore. So there's been a lot of changes in the wireless space as a result of this paradigm, different wireless technologies used in different ways, which is really the major change on the internet side. And we'll talk a little bit more about the thing side later, and then get into the word of, which is, in my opinion, the most important part of the phrase. But with the connectivity piece, because that's changed, where now we're no longer able to do terrestrial-based connectivity with wires and fiber. We're going more towards wireless. You also have to start to take into account some of the physics behind all of this. So how do we now get power everywhere? Because if there's a reason this device that we're connecting, or this thing that we're connecting, has to be wireless, then chances are power might have to be that way too. And so how do we get the power requirements so low so that the battery that is powering this thing, because that's the first step you would go to, isn't larger than the thing itself as well, or heavier than the thing. So if you think of a milk crate and you have to have a large car battery on it just to power the radio. That's not very smart or feasible. So how do we drive that power requirement down everywhere? And when I say power, I'm including both AC and DC, and also the concept of digital DC, which is a new paradigm that is opened up with power over Ethernet. And then finally, the last thing is compute everywhere. We've heard of the cloud, the edge, the fog. Obviously, if you're working a stamping press, you don't want the control signal to have to go halfway around the world or all the way around the world before a safety system kicks in. So where does that compute power need to occur at? What is the value of the data over time, and when will I be able to use that with regards to latency and the capability of when that data needs to be manipulated into something usable? So those three fundamental things have to now exist everywhere, which is really what's changed the internet side of things. So then we get to the other side of the phrase Internet of Things, and that is the word thing. And by definition, that is infinite. And so how do you grasp the connection of basically everything in the world? And so that's where I've seen a lot of churn across a lot of different companies, is at least the larger companies who are trying to battle this is, okay, we've got all these things that we work with. We got robots, we got manufacturing, we got our product. Where do we even start? And how do we get all these things connected? Well, I try to simplify it by going back to what do we know about nature? So Ford has done a lot with beekeeping and has, for environmental reasons, but we also learn things from these. And what can we learn from nature? And one of the things that we can learn is that we as humans have 5 basic senses, which allows us to connect to the physical world around us. So rather than look at all the different sensor capabilities that are out there and try and understand and get your head around all of those and how I might connect it to some other object to make it of some greater use, which could take forever, or going to the use case route, which is really infinity times infinity. How do I get down to a base core set of sensing capabilities? And so I like to think in the terms of we as humans have those 5 basic senses: sight, sound, smell, taste, touch. How could I recreate those with just a few core sensing capabilities to enable a lot of the connectivity that we want in the physical world? So a camera, for example, provides a digital sense of sight. And so I like to think of it more as an optical sensor. So when we go in, we're doing a proof of concept within Ford and we say we're going to set up a camera. Certainly HR and legal get excited about that, but we like to call it an optical sensor instead of a camera for that reason. But once you have that camera and you've used it in a way in which it's open and scalable to be applied to a lot of different use cases, now you've just simplified the concept of sight, and you can start connecting things in novel ways. You can start connecting things that don't really have a physical connection to them. So for example, a grain of sand, how do you connect a grain of sand to the internet? Well, you could do it through a camera system. That camera could be focused on that grain of sand and then give feedback to an AI system which can interpret what that sand is doing when it's being acted on by outside forces. So that's a way you can connect the physical world through a simple, open, scalable device, which could then be applied to a lot of other use cases. So again, we're trying to get down to what is the core things we can both get our arms around, that we can focus on, that we can develop, and also keep our costs down versus having all kinds of different types of sensors. And you may have seen this press release where Ford has moved along in those ways, where we've recently received a patent award on the sense of smell. And so the concept is not new to Ford. of taking technology and applying it to machinery. Henry Ford's been doing that since the beginning, replacing horses with tractors. Now we're at the point where taking these approaches, we can give our vehicles, our conference rooms, our factories the sense of smell so that we're able to do things that normally we would rely on humans or purpose-based sensors to do that work for us. Again, with the approach of looking at what do we need as people, and going back to our campus rather than our products, we found that one of the biggest challenges we have with our campus being spread across basically the entire city of Dearborn, people are moving from building to building a lot, and parking becomes the challenge. And so how do we solve parking problems? So again, using those use cases, keeping it people-centric, like was mentioned before, that not only solves problems that may not be related to automotive specifically, but eventually it could result in creating new product opportunities as well. If you've ever been to the Fairlane Mansion, Henry Ford carved into one of his mantles over his fireplaces the quote from Henry David Thoreau, "Chop your own wood and it will warm you twice." So back in the day, the physical sense of chopping wood and generating that heat from the motion and physical exercise, it warmed you up. And then when you burned your wood, it warmed you up. We're basically doing that same concept, only in a digital fashion. We're looking at what are our problems that we need to solve. We solve them for our company internally, and it provides some benefit. It warms us up. But then when we can then turn it back into a product offering, now we're being warmed up again because we're sharing what we've solved for ourselves into the rest of the world. And then with COVID-19, you've most likely heard a lot of the different innovations that Ford was able to put up relatively quickly. A lot of this was the result of ongoing research with IoT at Ford. And like was mentioned earlier, never miss an opportunity of a crisis. It's helped push along some of the technologies that we've been talking about and considering for a long time to move a little bit faster. So how do we get that connectivity in place in a company as large as Ford with the amount of investment and capital needed to do that? With contact tracing needs and keeping people safe, which is first and foremost. Now there's a business case behind that. So we've been doing different types of work with social distancing and training behaviors on how to be aware of how close you are in proximity to others, being able to just keep the workplace safer, looking at different technologies with masks and so forth. All of that is a result of having some IoT in place already that we could move and adapt quickly, but also in the same sense, COVID has helped push things fast forward a lot quicker than the rate it was going prior to COVID. So again, that's been useful for us. So to kind of start wrapping it up, ecosystems really enhance what the product is. So similar to what Joe was saying, I too like to focus more on what is the system around the product that needs to evolve. And in that, it opens up a tremendous number of opportunities. I do also want to point out that in the whole connectivity space, as Amazon is starting to roll out products, a lot of noise and things about, well, 5G is the way to go. Well, 5G offers a lot of opportunity and connectivity for IoT, but also we shouldn't dismiss some of the other technologies too, such as LoRaWAN, for example, and the 900 megahertz spectrum. Not everything is going to be video streaming, bandwidth intensive needs that will require 5G. So there is a lot of opportunity for some of the other frequencies. And so when considering the different ways in which to enable IoT, don't dismiss the fact that there are the physics involved with some of the other technologies. And so look at the use cases that you're trying to solve and how those other technologies can still play a role. And then finally, the disillusionment. So, you know, like I said, we've been connecting things, we've been making things smart for some time, back since 1978. X10 controllers were out there. I purchased a lot of those for my first house and started to get frustrated at the limitations of what I thought it would be able to give me. And then now here we are with smarter technology, yet I go and I invest in one ecosystem and find out it doesn't have that one feature I want that the other ecosystem has. But both of those providers don't work together. This I was just summarizing that from my point of view, working within Ford, we went from drinking fountains where it was safe to work on a drinking fountain. If we broke something, you know, somebody might be upset. If we went straight to manufacturing or vehicles and we broke something, now we're impacting the business. So using that minimal viable concept of prototyping, we were able to prove out some of our early concepts and move along solving those people problems in safe ways, and then introducing it into different types of product opportunities later on. And then the bottom line is, with the Internet of Things, in my mind, the biggest part of this whole phrase is the word of. When we talk about the Internet, not a whole lot is changed in that space. There's, you know, obviously we've been improving on capabilities and different types of technologies that we can use. And on the things side, that's just the world around us, everything that we can see and visualize, both for real and tangible and also virtual. It's that word in the middle. It's the of. It's why are we connecting things? When should we? And when will we get the value? Where should we be connecting things to achieve that value? Is it around the world? Is it in a certain part of the world? And then who benefits from it, both the consumer and the business? How do we achieve the value of connecting two or more objects together and having them interact in novel ways? So as Joe had mentioned earlier, sometimes it's not about just the ROI, the immediate ROI, but in some cases it may be necessary to stay in business to connect certain things in different ways because of disruption that's happening. But it also may be of strategic value to lay out this foundation in order to create new opportunities and be the disruptor. So again, it's that that is the most important thing. And then I don't have a slide specifically about security, but similarly, yes, security is a concern. There's a risk out there. It's the internet of things, not the intranet of things. So we need to think differently in terms of how do we protect things. We can't continue to think of things in the paradigm of we've got this castle and a moat and we're protecting the perimeter. We have to go to that paradigm of if you see something, say something. So how do we give objects that are connected the ability to sense one another, to determine what's an anomaly in the system, and how do I detect that and say something to allow these devices, which may have artificial intelligence in them and communicating at the speed of light, to make decisions and secure themselves. So there's a whole host of opportunities there. So with that, just open it up to questions.
Very good. All right, thank you very much, David. Everybody back online for Q&A. And one of the questions that came up that was both for Henry, it kind of fits into both Henry's story and also David's story. David, you were talking about these connectivity issues about 5G. And Henry, this is also something that comes up with when we start talking about connected vehicles. And we know that from our research on DSRC as a potential way of connecting versus 5G, I wanted to get both of you guys' sense of how that's playing out, either within IoT or maybe within the connected vehicle story. David, let's start with you.
Sure. So in my view of this, we need the entire electromagnetic spectrum. It exists and has different benefits and drawbacks based on which frequency and part of the spectrum you're using. So from my standpoint, I'm always promoting that don't dismiss other technologies. Yes, 5G, we're going to need it for high bandwidth type applications, but we also need things like LoRaWAN, where penetration through solids and the distance capabilities for things that large bandwidth doesn't matter. So you need to really look at the use cases. In the use case of if I'm going to take a small part, for example, and I want to connect it to the internet, and that part is going to need some power source, and it's going to need a radio to be able to at least wake up and say, hey, I'm here at the moment, or I've been moved. 5G might not be the answer, at least right now, because of the amount of power that it requires, the where this part might be located. It might not be able to penetrate the surroundings to send the signal out to the gateway. So then you might need to look into other technologies like LoRaWAN, which requires lower power, and maybe you can even get away from needing the battery, and the kinetic motion of just lifting that part and moving it alone could wake up the radio and send the message out to the gateway to say, hey, I've moved from point A to point B. 5G is great, looking forward to it, but don't dismiss all of the other traditional ways of connecting as well.
Henry?
Yeah, I think I would fully agree with David. We will definitely need the full safety spectrum, which was allocated to in late 1990s, and FCC's recent decision to allocate 45 megahertz of that into out of the safety band, and then utilize the remaining 30 megahertz for either DRSRC or CV2X, and these are I think there's obviously there are usage in terms of other use of this bandwidth, but for the safety critical applications, particularly with transportation, we really need to have that safety band spectrum. In terms of either this is DRSRC or CV2X, I think from technology perspective, we probably need both. There's development on both sides, and then DRSRC has been around for a while, more than 20 years, and then there's a lot of development on that, and CV2X in the recent few years, and there's a lot of potential on the CV2X, and eventually evolve into 5G as well. So I think both are probably needed, and both has their own advantage and disadvantage as well. And so from infrastructure perspective, we want to be technology neutral. We want to support both type of technology for safety critical applications.
Okay, thank you very much. Stick with you, Henry. When you were talking about the sensors from the ride-hailing programs and vehicles and gathering data that way, could you do the same thing with phones?
Oh yeah, well, the so-called ride-hailing vehicles is actually coming from phones. These are coming from driver's cell phone, and the driver's cell phone obviously has the apps on it, and then that's how the passengers, the consumers see where your vehicle is, and then when they will arrive to you, and even when you're en route, you see where it is. So these vehicles actually report back in terms of their location and speed information every through the cell phone every few seconds, and then we utilize that as mobile sensors to measure the traffic performance.
Yeah, that's the technology we used when we were are doing our research on the traffic apps and how well they were able to estimate your time of arrival based on traffic. And
exactly.
And this was data that I think the cell phone companies were selling to the mapping companies to be able to get this information. Is that something you see as being applicable to what you're talking about?
Oh yeah, definitely. Definitely. There's you know, right now there are a number of startup companies looking into the data coming from either from cell phones or from vehicles, from the new, particularly the new vehicles from OEMs, and then these are valuable data that you can utilize to measure traffic performance and utilize this not only for signal optimization but for a number of you know, urban transportation planning or management purposes.
Very good, thank you. David, question for you. Can you, this is from our audience, can you talk more about the financial rewards you see for Ford in IoT projects in general?
I can't say specifically for Ford, but in general, there's the biggest challenge is when you have a large company like Ford, for example. The question is always around scalability. So if I'm going to roll out, say, a new wireless technology like LoRaWAN, how do I do that? Who pays for it? That wasn't in anybody's budget. So what part of the business pays for it? Who's going to be the early adopter? Do we do it in pieces, so forth? And there's that question that has to be answered. The other question is with a large company, you have a lot of different vendors coming in to sell you the greatest shiny object, and everyone has their own network, their own backend, their own data model, and pretty soon you have 20 networks and all talking Bluetooth, doing the same thing. And so you really need to get people aligned. And so we've spent a lot of time, 3 years really, just getting people aligned in the company. I mentioned the dog sleds earlier, to understand who is working on what within IoT. And in a large company, a lot of times when somebody comes out and says, hey, what are you doing with IoT or whatever initiative it is, the first reaction of people is like, why? Are you going to stop my project? So we went in from the standpoint of, we're an enablement group and we're trying to just get everyone together and talk about what IoT is and help one another leverage the different things that we're working on, get those deviations that we need to go off and put our POC into production. But at the same time, we put up a bunch of different rallying points, like what is our current security model? What is our current data model, our data storage model, our networking models? And how does that fit within the framework of the IoT paradigm, and what needs to evolve? And so when it came to that question of, okay, now who pays for it? Now we can start taking these proofs of concepts and helping get the deviations across with the networking standards to put in a small segment of let's say a LoRaWAN network to prove out a use case, to show the business value as quickly as possible, to then go back and say, hey, we need to evolve this standard, and then the production people can go figure out how do we now scale it to the rest of the company, and then take some of those cost savings. So for example, if we spend hundreds of millions of dollars in energy usage a year and we're able to save 5% of that, then can we take those savings and put it back into the investment of building out that infrastructure? And that's when we'll start seeing operational efficiencies. Once we start seeing operational efficiencies along with providing new revenue streams. So for example, a parked car, I was in meetings where we talked about paid parking and how to monetize off of paid parking. And I asked the question, what about free parking? How can we monetize off that? And it's a new way of thinking that IoT enables you to say, well, yeah, there's other ways we can actually make money off of parking that nobody else is charging for, by providing different types of services. Like if I know where your vehicle is at the time, why is their vehicle there? And if I can sense, what other brands of vehicles are in a lot, why are those customers going to this certain establishment and our customers aren't? We can start gathering value and off of that, which creates then those financial opportunities for the organization.
Now you mentioned the issue of people coming to you with ideas, and but they have their own systems and their own back end, et cetera, et cetera. And one of the things that I spoke about earlier was the idea of auto companies and auto manufacturers using their supply base to bring in new technology, merging or working with tech companies, things like that. How possible is that kind of, how you remember how Microsoft would just buy a technology company? They would say, this is something we want to have, we're going to buy that. Do you guys see yourself doing that kind of acquisitions of, someone's just got this idea that you go, wow, this is a great idea. I don't want their back end. We just want the idea, and we're going to take it and we're going to run with it. Can you see that happening in the current structure?
Yeah, it does happen that way at times. In every derivation happens. There's that situation where we will purchase a company just for the technology and maybe do it differently. There are times where you purchase the company and you keep it as a independent, so wholly owned company. There are times where we've had vendors come in with solutions and we like the concept of what it does, but it's not the best way to do it. And so we'll actually build a working prototype. We might even burn our own circuit boards to go back to that vendor and say, no, this is how we want it. Instead of by PowerPoint, it's like, here, this is a fully functional built system, but now you go scale it for us.
All right, very good. Henry, I got a question for you. You were talking about your test scenarios and the modeling that comes out of those, right? And how does that compare to the testing that's being done on the road by Waymo? Oh, did we lose Henry? We lost him. Oh, now he's answering. We can't answer his question now. I was curious about that because he was talking about being able to do things differently in modeling, especially in adversarial situations that don't happen very often on the roads today, and how that might compare to. I think he was arguing that by modeling they can do things a little quicker and do things and in ways that Waymo has to wait for one of those situations to occur to see how the vehicle reacts. So you end up having hundreds of millions of miles of vehicles to be able to create enough of these adversarial situations to see how the technology works and how to adapt the technology. David, your story about the pandemic was an interesting one. I thought that how the new ideas that came up because of the pandemic was very interesting. In terms of shared vehicles, do you see some opportunities there for IoT?
Yeah, like the smell sensing, for example, is one of the use cases that kind of drove that research. If I get into a shared vehicle and it's offensive to me odor-wise, I may be looking at the Ford logo while that's happening and associate that negative experience with the brand, and so that's something we don't want. So how can we create some method to prevent that type of situation from occurring? But there's a whole host of opportunities. What was your original question again? I'm losing my train of thought.
It was how did it affect shared vehicles?
Oh, with the COVID situation?
Yeah.
So one of the things that we hear a lot of controversy about is masks and whether they're helpful or harmful. And certainly from the standpoint of a worker wearing a mask, all day long in a facility, if it causes respiratory fatigue, there could be a hazardous situation. But also in the vehicle, if you have a shared owner or say an Uber driver who's wearing a mask all day long driving people around, what's happening to that person? Are they, hopefully it is blocking pathogens, but is it also causing them to go into some type of respiratory distress where they might end up getting into an accident or something? So actually had one of my interns from U of M work on some research with smart masks and understand what is really happening in terms of CO2 levels and so forth, and to really truly get down to the science of it and see if there's that opportunity for creating a better mask, or at least alerting the driver to, hey, you might want to pull over, take your mask off for a few minutes and breathe fresh air. So there's those types of opportunities. As well as contact tracing itself, but doing it in a way that protects privacy. Privacy is a huge issue within Ford, so it's foundational to everything we do. If we're using the vehicle as a contact tracing mechanism, we want to make sure that we're doing it in a way that protects people's identity and privacy in that respect. So that's certainly an opportunity, and whether we're exploring it, I'm not aware of from my position within the company.
Sure. All right, very good. Thank you very much, David. Let's take a 5-minute break and come back in, I got 11:38, so let's come back in around 11:45 and start up again.
Thank you very much for inviting us here. We look forward to the discussion, and maybe I should mention in the very beginning that we will be looking at the IIoT from a little bit different perspective than it was done so far. We are not engineers, we are social scientists, or to be specific, industrial sociologists. And in our research group here in Berlin, the BZB Berlin Social Science Center, our core topics are the impact of digitalization, Industry 4.0 on work organization skills. But we will report from one project which focuses more on the innovation activities, innovation processes in the industry, which examines the emergence of a global innovation system around IIoT. And our major question is how German manufacturing firms, and we will look as well at the machine building firms as at the automotive firms, how they position themselves in this multi-layered ecosystem of IIoT. We have this focus on German manufacturing firms, this interest, because we think that the development of IIoT is a big chance for firms, and we discussed it already, but it also creates a number of challenges. And we have a huge debate in Germany about how firms have to change their business models, build up new competences, and how the German manufacturing industry, which is one of the core sectors of the German economy, can avoid also developing one-sided dependencies from IT firms, from hyperscalers like Microsoft Azure, AWS. So how the manufacturing firms can come in as players in the IIoT field. And Grzegorz will start and then presenting our first findings and our hypothesis. He will look at the IIoT value chain and at the role of German companies. And then I will take over, discuss then the European perspective going into industrial policy, also into one case of an automotive manufacturer, and closing with a few remarks on the skill challenge related to IIoT. Yeah, so Grzegorz, you now take over.
Okay, thank you, Martin, for the introduction. And as Martin has already mentioned, our specific question in this research project are the positioning strategies of German manufacturing technology producers and also of end manufacturers, which includes also automotive producers within what we call the multi-layered technological ecosystem of IIoT. So to begin with, let me explain what we mean by this multi-layered IIoT ecosystem. We distinguish here between two interrelated aspects, and the first is the technological architecture, and the second is the organizational structure of the ecosystem, by which I understand the relations between organizations involved in the supply of IIoT technologies. So in the first step, let me focus on the technological dimension, which is what I am now showing on the screen. This is so maybe first let me briefly present our definition, our understanding of what IIoT solutions are. So we understand them as complex information systems which use data from various connected manufacturing devices to perform local and remote computing processes, and this in order to deliver various kinds of smart services, which includes services such as device monitoring, predictive maintenance, but also an analysis of industrial data for various external commercial purposes. And importantly, these IoT solutions can be described as multi-layered architectures, and this is now exactly what the slide on the screen is showing. This is our simplified view of the IoT architecture for our, let's say, sociological purposes. And here we distinguish between three technology layers. So at the bottom layer, there are interconnected devices. And here we have robots, machine tools, together with their control systems. And then there is the middle level of the IIoT edge, which collects data from the devices and performs some basic data analysis close to the data source. And of course, the general advantage of doing the analysis on the edge and not sending it to the cloud is that you can avoid latencies and also security issues, which are two critical questions from the perspective of factory and the manufacturing equipment users. And then on the very top of the diagram, we have the cloud itself, into which at least parts of the factory data are sent and then combined often with other data sources and analyzed in order to provide some insights into manufacturing processes at the device level, and then maybe also to use these insights, as I suggested already before, for various external commercial purposes. And regarding the advantages of the cloud, of course, overdoing the analysis on the edge layer is that at the cloud layer, the computing capabilities are of course much larger, and it makes sense for various reasons to send data to the industrial data to the cloud, despite the technical and security related issues. And last important element of our architectural perspective on IoT are the so-called IoT platforms, which is the element I'm introducing here on the left side of the diagram. I have intentionally decided not to make platforms too central in our structure, although they are very central very often in social scientific discussions about IoT. But our view on the platforms is that platforms are actually business constructs, and they are we define them, strictly speaking, as bundles of IoT functionalities that may be constructed by firms and introduced in various segments of the IoT stack. So we introduce in this way a sort of lean definition of IoT platforms. We do not define them necessarily as markets or other kinds of structures. This is a technology and strictly speaking, technology-focused definition. I will come back to the platforms later. Regarding the, let's say, methodology and our research approach that we are taking in this analysis, we are building on this and general understanding of what IoT technology is to reconstruct relations between firms involved in IoT, which means both technology producers and end manufacturers. And our general assumption here is that the technology supply chains around IoT will be highly fragmented between various kinds of firms specialized in different kinds of technologies. And second, that these chains will also be organized on the global scale. So by this, I understand that while we are taking the perspective of the German producers of the technology and the users of the technology, we expect the relations to be transnational. So for instance, relations with multiple multinational IT companies will be probably there in the IoT supply chains. So, and regarding our methods, we are doing interviews with experts and companies, and also building a database of secondary sources on the German IoT sector. So based on the data we have analyzed so far, we were able to identify some general organizational and also political economic dynamics taking place around the IoT sector in Germany. And I will now introduce the first three elements, and Martin will then take over with discussing the political economic dynamics and the perspective of the end manufacturers, focusing on the automotive case. So the first of the, let's say, organizational dynamics that we have observed taking place between the suppliers of the IoT technology is a specific vertical specialization pattern developing in the German IoT sector. And more precisely, there is a small group of US-American IT multinationals, strictly speaking, two of them, Microsoft with Azure and Amazon with AWS, who are gaining dominant positions as cloud infrastructure suppliers to a number of lower level and more manufacturing specialized German IoT platforms. So there is here not so much a competitive relationship between the global players and the German players, but rather a mutualistic one. So the Amazon and Microsoft, they are providing cloud storage and various kinds of infrastructural services on which the more sectorally specialized platform players build their own solution. And now on this slide, as an example, I'm showing you a selection of the lower level IoT platforms who are actually using Microsoft Azure in this case. And this is a group of large industrial automation providers. Here we have both US and European companies who have entered the IoT platform business, but without doing their own cloud infrastructure. And regarding our second main observation, which is now the second box on the screen, this is about organizational dynamics among the German IoT platforms. So in general, we are talking here about the relatively more specialized, let's say lower level digital manufacturing platform and providers of these platforms who come mostly from the German manufacturing technology sector. There have been a number of this kind of entrants into the IoT sector in Germany since around 2015, and their important advantage over the global cloud providers is, of course, that they can rely on their previous experience in industrial machinery and developing industrial software, and are therefore able to develop IoT solutions more tailored to the requirements of manufacturing sectors. And now on the screen, I'm showing you two important examples of such German IoT platforms. The first one is Siemens with MindSphere, and the second one is a more recent newcomer, an alliance of small producers who established a platform brand called Adamus. And what the figure is showing are also the coalitions of complementing manufacturing technology and IT producers that these platforms have built around them. And one interesting observation we have made here is that these coalitions of actors still seem to be have a rather regional, not maybe even domestic character, so that we are seeing here German companies or German platforms allying with German complementers mostly still. But importantly, what we are observing regarding the organizational dynamics is a kind of industry shakeout that is taking place in the German IoT platform market. So In other words, although many producers have made moves to develop IoT platforms, many of them were not really successful in this market. And one prominent example of this is a well-known German machine tools producer, Trumpf, who entered the platform market around 2016 and who tried to introduce an open IoT platform that integrated also third-party technology, and it was also meant to become a market for third-party applications. In doing so, the company didn't want to provide its own infrastructure, but relied here, as other German actors, on external providers. But most importantly, now from our perspective, this IoT platform survived on the market only for about 3 years, and then the company abandoned the own platform concept and joined the IoT alliance by the larger player Siemens with MindSphere. We are seeing, in fact, other cases of platform market exit, and this leads among the German IoT platform providers, and this leads us to a preliminary conclusion that there are consolidation processes taking place in the German IoT market. And now our third observation before I hand over to Martin regarding the interfirm dynamics from the perspective of the German technology firms is that there are new competitive opportunities developing at the level and processes developing at the level of IoT edge. And because we are running short of time, I will be very brief here. So in general, we are observing here entries both from the side of the more traditional manufacturing technology producers and global IT players. And the hypothesis that we are now focusing on in our analysis is that maybe contrary to what one could expect, not the traditional hardware or connectivity suppliers seem to be gaining the lead here. We are currently observing a sort of migration of the higher level cloud solutions to the IoT edge layer, and we have a more specific hypothesis that the technological advantage of the global IT players over the more specialized manufacturing technology producers is related to the multinationals' capabilities in providing such critical back-end components as AI or machine learning services, which are components very difficult to develop for the smaller German manufacturing technology providers. Okay, this was my last remark. I will now hand over to Martin, who will continue with his remarks on the industrial policy processes around IoT.
Thank you, Grzegorz. Maybe one question, of course, is why do platforms such as the mentioned Trumpf case fail? And what we observe is that the IoT market is not taking, let's say, not developing such as many companies hoped. And I think there is a lot of problems related to hesitation by companies due to the question, do I control my data? Maybe also to the question of what's really the added value of the huge investment required to the IoT. There is also an insecurity which competences are needed, and I will discuss this a little bit. What I want first to mention is that, let's say, from the point of view of a German or European companies and policy, industrial policy is an important element of creating a safe, transparent, and functioning IoT market. We actually have a long discussions in Europe about the question who will dominate the IoT value chain. Grzegorz mentioned there are fears about the powerful position of providers, cloud providers like AWS, Microsoft. Companies like Siemens and others have tried to challenge this position so far with limited success. And this is of a huge concern for the German government, also for the European governments. This has been even intensified now with the trade wars and also the questions about data sovereignty, European data sovereignty, but also the reliability of the US and international cooperation. So an important approach of German and industrial and European industrial policy was to promote standardization, to avoid the development of insulated solutions where single companies might get control of the market and create lock-ins. Also, the hope is that by pushing forward the standardization of IIoT, the market for IIoT solutions might develop, and also this might be an advantage for German Mittelstand, middle-sized companies, equipment builders, manufacturers, if they succeed to be the first also to implement the standards which gain acceptance in the market. And I just want to mention briefly two initiatives regarding this standardization concepts. One, you probably know, so it's the Platform Industry 4.0 approach in Germany. The Platform Industry 4.0 is an organization which includes government, industry, also industry associations, but also a number of individual companies, and which promotes the development of different standards, like the OPC-UA from the shop floor networking, but also the development of standards for what is called digital twins, which means the connection of data or from the whole life cycle of a product or machine. So this is one field, promoting standardization in order to create a level playing field to avoid, let's say, proprietary solutions. But I just want to mention another project which is quite recent, which maybe you know, which is Gaia X, which was launched last year and which is strongly pushed by the German government. And the basic idea is to create a kind of European data infrastructure, which means to kind of open, transparent, and secure marketplace for cloud services, where different cloud providers, a kind of meta cloud, you could say, where different cloud providers would offer their services, infrastructures, and the customers could easily select not only the price, but also, and this is important from the European perspective, the levels of data protection, the localization of servers, all the issues which currently hamper the development of this IIoT market due to concerns about data sovereignty. Yeah, so I think this is an important answer or an important approach in Europe to get this IIoT market into real life. What do, George, maybe you can switch. What do the car manufacturers do themselves? I think this was already mentioned that actually companies pursue a kind of double strategy of building up own competences and cooperating where they need it with the hyperscalers. And actually we observe currently in Germany a number of quite ambitious projects of building IIoT infrastructures. And I would like to just briefly to illustrate this with the case of the Daimler Factory 56, which also probably you read already about. So it's a huge investment made by Daimler, 730 million, I think, for the creation of this plant, which is now in the SOP phase, and it's meant to produce the S-Class, but also the Maybach models and a new electric vehicle brand, the EQS, which is announced for 2021. And the plant is meant to become a model plant, if it works, for the Daimler factories in the future, and to be then a template for future developments. So actually, so what are the core elements, core innovations in Factory 56? So maybe the first point to be mentioned is that I think it's, as far as I know, the first plant with an own 5G network, which was established on the factory premises as the basis for the IIoT infrastructure. I don't know if this is particular for Germany, but Germany sold not only 5G licenses to telecommunications companies, but also manufacturing companies can and could buy 5G licenses for own on-premises networks, which most big producers did. So Daimler established with Telefonica and Ericsson an own 5G network, on the company premises with a central 5G hub and several small cell indoor 5G antennas in order to allow quick transport processing of huge data volumes with very short latency times. The second element is huge investment in creating own modular software platform, which makes usage of the IIoT functionalities. It's called MO360, then Mercedes-Benz Car Operations 360, and involves various modules like a quality monitoring system based on IIoT data about product process quality, which creates warnings if certain parameters suggest a quality problem, and is linked to an AI system. I will talk about this running on a cloud. It includes a shop floor management digital system, which collects all production related data, a smart maintenance module, which is fed permanently from the equipment in the plant. The data is then collected in data lakes. So for instance, I know a conveyor system would, for instance, transfer information about carrier numbers, hours of operation, travel distance, temperature of drives, etc. And the software will then monitor the state of the equipment and will inform the maintenance department if parts have to be changed, etc. Then there is a digital communication model, because actually what the company tries is now to equip all shop floor supervisors with tablets. Many workers have smart watches or smartphones in order to accelerate the access to data. And there are also some other models like a Kanban, RFID-based Kanban system for logistics, etc. I will not maybe talk about, I would also, actually I plan to mention also a certain process innovation linked to the IoT. Maybe we can come to this in the discussion, which is the creation of lines which are not longer based on a fixed conveyor system, but which can exploit certain flexibility based on the information which the IoT provides about a car coming, which can be directed to different stations based on the AGVs. But I will skip this and mention as a last point that, of course, while this system was developed by Daimler, is running on a private cloud, Daimler is also, of course, cooperating with the hyperscalers for the connection to the bigger cloud. Here it is Microsoft Azure, and here Daimler is building or has built an own platform using the Microsoft Cloud and its functionalities, its microservices for AI and big data analytics, and is trying, let's say, to maneuver between own developments and the cooperation, the potential dependency from a bigger hyperscaler like Microsoft. And maybe as a last point, I have mentioned that German companies try to invest a lot in building own competences in this field and are quite aware about the dangers of potential dependencies. Of course, this is also related to a skill base. And what I just want to mention to finish my presentation is, on the one hand, the enormous change in the workforce of the German automotive industry. So when we look at the statistics, the employment of engineers and computer scientists expanded enormously from around 12–13% of the automotive workforce in 2000 to around 20% in 2018, which a development which was, as far as I know the numbers, much faster than in the American case, where the engineering and computer science employment is not expanding as fast. But despite this huge investment in changing the workforce, we hear all the time complaints about the lack of competences in software development, and also in particular about the lack of people who can combine knowledge about automation technology and software development. So there are software developers from the universities who never saw a PLC, and also automation engineers who do not learn software development. And the combination of both is actually what companies need. And what we see here in Germany is also huge efforts to adapt the educational system. So we see how universities invest more and more into provide combined IT and automation education. And we see also how companies invest in adapting the vocational training system, into shifting more resources to more IT-oriented occupations, for instance, employing not only mechatronics and industrial mechanics, but also computer science experts in maintenance or commissioning. We see also how the way how vocational training is done is changing. For instance, Volkswagen is running a campus where mechatronics, industrial mechanics, computer science experts come together for 3 or 4 months to form groups, joint projects related to the IIoT. So simply because all these disciplines have come together and learn how to cooperate in this new field. And I will conclude here and just emphasize that from my and Grzegorz perspectives, IoT is a dynamic field with chances and risks. So we have these big chances related to efficiency gains, quality gains, maybe completely new products. But there are also risks related to new dependencies in the IoT value chain and huge challenges for manufacturing firms regarding how to develop an own skill base and how to master let's say, how not to lose control of their data, their product, their markets. Okay, thank you very much, and we look forward to your questions and the discussion.
All right, thank you very much, Martin. You know, I was thinking that it'd be interesting to have Trevor give his presentation and have you and he combine on the Q&A.
It's perfect from our side.
Yeah, I think that would be, I think it'll be interesting. So let's turn off your screen sharing, Grzegorz. Yeah, and Trevor, let's go to you.
Okay, sounds good. Can you hear me okay?
Yep, very good.
All right. Let me share my screen here.
All right.
All right. Well, thanks, Bruce. Appreciate the opportunity to present here again today at the Automotive Research Conference. So my name is Trevor White. I'm the Divisional Information Officer and Group Manager responsible for manufacturing systems here at Toyota in the IT experiences organization. I also have a couple of side roles. One is our lead for our Industry 4.0 Factory of the Future program within IT. As well as sit on the board of directors for the MESA organization. So again, thanks for the opportunity. As we start to look at our Industry 4.0 program, there's a significant amount of disruption that's occurring now in the automotive space. There's competition from Tesla, from Google, from Apple, Uber, specifically non-traditional competitors. Customer expectations are changing. There's a shift to ride sharing. It's all about experience over quality. There's long vehicle order lead times, especially right now. The tariffs and government regulations, we have to respond very quickly and flexibly from a factory floor perspective. So we started this program a few years back and, you know, didn't even realize at the time how much it would be disruptive, especially recently with COVID-19 and how our plants are being transformed and relying on more IT technology than they ever had before. So what is, for us, what is Industry 4.0 is a big question I get asked internally as well as externally. And it's, you know, has a number of different names, smart manufacturing, smart factories, digital factory, factory of the future is the term that we've been using recently. But they all relate to combining the physical OT and the cyber or the digital twin to the IT systems introduced previously in Industry 3.0. The goal is to develop complex insights from our industrial big data to build predictive and prescriptive insights. We want to use machine learning and AI to support that activity. For us, this includes things like vision systems, autonomous robots, picking systems, virtual reality, collaborative robots, as well as, you know, resulting from our pandemic, the new focus on thermal imaging, social distancing, tracing tools, We want to leverage that real-time big data and analytic dashboards within the factory floor. So a strong focus on this area, and we want to make sure manufacturing is becoming more agile, more scalable in the future. So what are some of the benefits for us on the factory floor? It includes real-time data-driven decision-making. We talk about this frequently right now in our environment. Technologies like AR and VR are able to bridge those cyber-physical gaps. We can overlay 3D design data with standardized work processes. We can provide dojo, we call it dojo training, with technologies like HoloLens recently. We talked about Microsoft HoloLens and their capabilities there to eliminate having physical training and having more virtual training. Real-time visualization on the plant floor. We use Power BI within the Microsoft ecosystem to improve decision-making. Data is not just collected like we have in the past, but it's actually contextualized, and it's correlated using machine learning and AI algorithms. Specifically in the predictive maintenance area, where we've found a lot of benefit recently. So that results in faster, we call it PDCA, plan, do, check action, and more robust processes within our factories. So what do we have to put in place to support all of these efforts? It's really this, what we're talking about is this IIoT platform that enables all this factory of the future. Within internally, we call it production engineering unleashed. So it's unleashing our engineers on the floor to be faster and more capable of utilizing these Industry 4.0 technologies on a common platform. So we've done a lot of benchmarking with partnering. We see a significant potential for up to a 20% increase in productivity. And as you can see over there, $800 billion in potential value that's created out of this program. So what does our platform look like at a high level? I'll share with you the high level kind of view of what it looks like. So we're building out our IoT platforms as we speak. We've partnered with Microsoft and AWS, as was previously mentioned. We're moving existing data from previous siloed systems into our data lakes. That's enabling those advanced insights we talked about through tools like Power BI or Tableau. This platform is definitely currently evolving. So it's providing new capabilities, as you can see on the left-hand side, with the edge gateways to collecting kind of time series data from our PLCs, enabling AI and machine learning on the plant floor at the edge. Our industrial big data is collected into what we call our Toyota Big Data Platform through both local and regional data lakes, regional or global data lakes. We want to aggregate that factory floor data up and then combine that with existing data structures like our customer data, our vehicle data, or warranty data to drive those advanced insights. The application infrastructure does provide that machine learning modeling, the analytics. Today we have over 70 models being used in this environment, and we're currently working to move a lot of our legacy manufacturing data from equipment onto this platform as we speak. So to date, we've proven the value of this program through several use cases. It's probably the biggest question I get asked is, so where's the real value, right? And to date, we've already been able to reflect over $50 million worth of value, either avoidance or actually avoiding downtime or cost reduction through some of the activities, specifically in the predictive maintenance areas. Our powertrain analytics area has been very fruitful area, as well as the energy areas. Our next step is continue to partnering with our engineering group from an IT perspective to build out the platform together through additional use cases. We have a very long list of use cases that we're moving forward on. Some were hindered with COVID with some of the cost reductions that we're doing, but we're moving forward with some really good, strong use cases right now. Next slide. So for our IT, let me talk a little bit about kind of the program. So for our IT team, our approach is to focus on production-ready technology through benchmarking and partnership with companies like I mentioned through Microsoft or AWS. Our engineering team has developed an innovation lab to help facilitate that and to follow that and expand our technological capabilities, including visualizing or showing this platform in our lab and how it would work with our existing equipment on the plant floor. So another big question I get asked about the program is so what do you see are risks to the program, or what are the biggest challenges related to this program? And to me, it's the changing of the culture of our users, right? It's shifting to that data-driven decision making. From our perspective, some of the best practices related to that include developing and communicating a clear and compelling Industry 4.0 vision, incorporating that into the culture of our company. So for us, it's the Toyota Way, or our Toyota Production System philosophy. We want to train our workforce to develop the capabilities and skills that are needed. We even term the phrase citizen data scientists, right? We recruit people from the factory floor to do data science roles. We want to make sure we involve our key stakeholders, make sure you have executive sponsorship, understanding that processes in many cases may have to change to support the new technology, and just breaking down the silos between traditional engineering groups, the OT side of things, and our IT group, and changing that culture. And then finally, in summary, I'll share just a summary of the activities. So what we're trying to do is to build that robust, flexible factory of the future. We want deeper insights from connected systems. We want team members empowered with real-time visualization tools and advanced analytics. As I mentioned, reducing the time to plan, do, check, action, PDCA, and improving our response time is ultimately, resulting in that data-driven decision making from the source system. And through that, we see a lot of opportunity: safety, maintenance, quality, higher yield, on-time delivery, which is a big focus right now with the increased demand, especially in the truck market. Reduced cost cost per unit CPU, and of course higher margins. And you can kind of see some of the technologies that we're working on today. So that's a little bit of overview of our program, and I'll pause there and Bruce, and see if we have questions maybe for both of us.
All right, sounds. Okay, sounds good, Trevor. Thank you. All right, let's stop sharing your screen.
Okay.
And then we'll do some Q&A here. Now, Trevor, I want to start with you because you're a repeat offender on our panel here. And last time you were here, which was, I think it's 3 or 4 years ago.
Yeah, it's been a few years. That's right.
Yeah, and it sounded at that time that you were just getting into convincing Japan that this is a good plan for the short term and the long term.
That's right.
And Japan was receptive once you gave them some good use cases and showed how things were working. And how has that evolved in this over this past 3 or 4 years? Yeah,
it's a great question, Bruce, and you're exactly right. We've had over the last few years, we've had a lot of visitors from Japan, I'll put it that way, into our North America market, and to understand this program. And what ended up resulting from that is an invite to send one of our members to Japan and on a long-term assignment, and put in a position where they were dual capped within IT and production engineering in Japan, and started a global program called our G-Smart, Global Smart Toyota program. And identified a number of use cases where our European counterparts, our Japan counterparts, our North America, Asia Pac members are all participate in that, and really standing up a global platform to share code, to share models, using tools like GitHub, for example, as one of our tools that we're using within this G-Smart environment. So that's progressing. And then of course the sharing of best practice use cases for factory floor automation has been a result of that as well. And each region within our Toyota global environment has been able to benefit from some of the good work that we've done here in North America.
Very good, thank you. Martin, when you guys were looking at what was going on in Germany, were you seeing any particular challenges between IT and engineering?
So on different levels, huh? I think in the factories, what we see is actually that given, so automotive manufacturers are not always the most attractive employers for people studying IT things. So those people may want to go to Google, to others. And I think becoming an attractive employer for attracting, good people in with IT skills is a challenge. And then what we see in particular when we really go into these IIoT projects, that you need people with, this is an issue of culture, but also of education, which understand the automation world. So when, as I mentioned, when people study, I don't know, computer science or whatever at the university, they often never saw a machine, a PLC, and they do not know how to cope with it. And then the automation engineers also usually are not really familiar with how to deal with more sophisticated software architectures. And bringing this together is a question of education, and then also of culture, huh? So how people are used to work, what they expect. So often we hear about, I exaggerate a little bit, very, very shy guys, computer scientists going to the shop floor and getting, I don't know, some getting in trouble with the production people who say, oh, this doesn't work. And so then they complain about the tough culture on the shop floor. Yeah, there are tensions. But as I mentioned, on the higher level, there is also this, let's say, this open question: how far can automotive companies really acquire and develop these skills? Mm-hmm. And this would be, maybe, I don't know if Trevor can comment on it, what you see here, because in North America or at Toyota, because this discussion, which I mentioned also on the industrial policy level, this is also something the companies are discussing. What can we do ourselves? And how far are we becoming dependent, for instance, when we build up this AI, big data analysis? Can we do it or not? It's a highly contested issue. And I think the last word is not spoken on how let's say, how independent automotive companies will get, or how dependent they will become on software and IT companies.
I was seeing that as well in both your presentations, where it seemed like the nuts and bolts of IoT is being done internally, but then the machine learning, the AI gets outsourced. Trevor, did I read that correctly from you guys?
Yeah, I think for us, it's a blend, right? We've partnered with a number of companies, as well as offshore, onshore, nearshore companies that we use to build some of the models. But right now, some of the initial modeling and use cases that we've been focused on, we've really tried to do that within our internal environment, but we're heavily sourced from a developer perspective anyway. So a lot of our folks that are building the models are contract staff or partner companies that support our IT organization, just because of our heavily outsourced kind of strategy. But yeah, it's really both. You have to partner with some really good companies, some partner companies. You got to have good people internally that are doing the education piece, which Martin talked about, that I think is hugely important, and probably one of the most underrated things that when we started the program for us, that we had from a reflection perspective.
Bruce, if I may?
Sure.
Yeah, I'd like to kind of reflect on what was just said. Going back to a question that was asked of me earlier in the conference about the growth, the scalability of IoT, and to some extent, Industry 4.0. I think that what we're seeing are signs of very, very early adoption stage. Reflecting on some of Trevor's slides as the visuals, this is not specific to Toyota, and some Martin's and the George comments, you see how many different tools, whether best of breeds or not, involved, how much additional work is done for integration, semantic translation, outsourcing. This stuff, this model is not scalable. So we'll continue to create islands of success. I have no doubt that Toyota will show islands of success. And it will be, and again, I do not mean to criticize because that's the nature of industry as we stand. But those will be successful, but will not scale. Perhaps will scale within maybe a product line, maybe within a certain domain, but it's going to be very hard to build a scalable infrastructure. So in terms of where we are in the adoption and the ability to kind of break through the next level and become a reusable platform type solution, I'm afraid we're really, really far away from it.
I was looking at the Trevor's slides about kind of how far along they are. You know, Trevor, you were showing the kind of the green area where you've done some work, some really good work to justify, and some cost savings, right? That you've been working on and shown. But it looked like there was a really long list of other things that were still to come. Is that an accurate assessment?
Yeah, that's exactly right. You know, there's still a lot of opportunity, and I think partly we had a little bit of an organizational issue that is remedied itself this year through on the business side within production engineering, where they've spun up a new manufacturing production innovation center on the business side, where they're really making a concerted effort to get some of this new technology into our factory floor. So I fully expect this to increase in speed with the introduction of that new organization and our team to support it. We've kind of been out on the forefront within IT, kind of talking about all this opportunity, and not got a lot of support until we had that organization in place. So I fully expect that to increase. But you're exactly right, Bruce, in terms of what it looks like today.
Did you have any challenges in terms of getting credit for the improvements? Sometimes, you know how it is in large organizations where, you know, who's getting credit for what we're doing. Does IT get the credit? Does production engineering get the credit? And then based on that, how is money allocated, you know, based on that?
Yeah, it's a great question. Not so much for the credit side of things, but more from budget and benefit is a big one. So, you know, to date, you know, IT has funded all of the budget when it comes to the platform and deployment of the platform and architecture, and then our engineering groups kind of have to bring their budget when it comes to the actual, you know, automation on the factory floor, when it talks to machines and robots and the partner companies from that perspective. So, but what we've seen is that IT brings the budget and business gets all the benefit, right? So it's been a little challenging. We've toyed with some different models around, you know, reinvestment models where we take 10% of the benefit that businesses gain and ask them for them to reinvest into the program within IT. So we'll see how that goes, but that is some of the challenge that we have from a funding perspective.
That's exactly what Joe was talking about in his presentation earlier, where, you know, we always talk about IT as an enabler. And if it's enabler, well, then it means it's enabling something, and something is getting enabled because of this. And that means there's maybe some money being saved because of this. Maybe you need to take some of that savings and put it back into the system. And I think Joe was talking about that earlier.
And so was David. So I think that one of the question is, you know, what's the contribution to the strategic investment bucket, which we tend not to do that. We talk about IT versus engineering, who gets the credit, as David was saying, who's going to pay for it. Mm-hmm. And we don't have a budget line item called strategic investment. And I think David was also talking about this notion.
Yeah, David, did you have something you wanted to say on that?
Yeah, it's so just in the data alignment role, I was in a previous role where we're trying to align data from a semantic definitions standpoint. The only way we could get the resources necessary to do that was to start charging for any IT project that there is some data element associated with that project. And so there's basically a tax tapped onto any project in order to get the funding to move forward. So I don't know that that's possible with IoT because it's a lot more capital intensive, but there needs to be a breaking point.
Yeah.
By the way, if whether it's Ford or Toyota, is there also kind of between the lines whose head is going to roll if we fail? Is this also part of this conversation?
Not for us. It's a good question. At least for our side, there's been definitely a fail fast type of mentality and especially I mentioned in the lab environment.
Fail fast is an interesting phrase. I haven't heard that one before.
Yeah, so that's the mentality we want to have with a lot of this, is that let's trial it in the lab or in a small plant environment first, see the benefit of it, and then once it's successful and proven successful, we call it Yokoten quickly, right, to all the other locations.
Yeah, Grzegorz, I had a question for you. In the slide that you were showing the three different levels, and the end point was external purposes of services. What kinds of things were you thinking of in those examples?
I mean, one example we had at one of there was a collaboration that was developed around a platform that by a relatively smaller German manufacturing equipment producer. Finally, the platform didn't work that well, but the collaboration was between the manufacturing equipment producer. Among other actors involved here was insurance company. And I think that, using data on how production, on how machinery works, for instance, insurance, that would be just one case for providing insights into, financial actors or exactly insurance actors that could be one area of application.
Yeah. Martin, one thing that I was thinking about was the effects of Industry 4.0 on labor. And it's not necessarily an IoT story, but it probably is connected to it. How is labor responding to this?
So at least, I don't know, maybe this is similar everywhere. So on the one hand, I feel like we have a huge debate which always emphasizes potential automation related losses of employment. But I have to admit, so far, if we look at least at Germany and the impact of Industry 4.0, we do not see this huge impact on employment. So for instance, just I think electric mobility, when we do not have then combustion engine, this will, of course, this kind of product change, I think has a much bigger impact on employment than what we see, let's say, in IoT field, Industry 4.0. There is one thing I am really curious or I'm wondering where it goes. I mentioned already the huge expansion of engineering and computer related occupations employment in the German automotive manufacturing. So it seems as if all these projects, which we have since 20 years on digital factory, now Industry 4.0, increase the employment number of engineers and computer scientists. So sometimes I wonder if this is simply because German companies are over-engineering. So they build up huge capabilities, huge staff, to manage all the challenges they are seeing, because I do not see so many efficiency gains in the field of engineering itself, at least from the big numbers. This is not so much in the focus of debates, which are always concerned about the workers working with robots, but robots we have in the car industry since decades. So this is, I think, a little bit overlooked, what happens in the engineering, in the IT departments, and what IoT might mean for these areas. And so far I see only expansion, so no employment losses.
Trevor, how's that playing out for you in the US? And also, if you can, talk about its effects in Japan.
Yeah, so I'll talk about it more from the IT perspective of things, and then maybe from the general view from my perspective. So from the IT perspective, as I mentioned, we have to really work with partner companies. We actually partner with, for example, Hitachi has been a great partner of ours, and as well as I mentioned, Microsoft. But having those companies provide staff that have the capabilities and the knowledge and the skill set, in this space has been very, very critical for us on the IT side. On the flip side, from the business perspective, what we're seeing is really a shift in worker style. So, for example, we're working on a big project right now around logistics automation. We're moving to more autonomous vision guided vehicles on the factory floor. And as you could probably think that a lot of this would displace traditional workers, but on the flip side, it's requiring us to hire more engineers that have robotic controls engineering type of capabilities and versus the traditional worker that you would have in the past. So we'll see how much that plays out in the future, but right now we're having to just shift the type of worker that we need on the factory floor more towards an engineering, and it's hard to find those folks. I know I just saw an email this morning around University of Kentucky, who we partner with here. I'm in the Kentucky plant here, and we're giving quite a bit of money just to sponsor the engineering automation technical field, so that we can find folks that have that capability right out of school and get them into our factories.
How's it playing out in Japan? Japan traditionally has been not as focused on IT, and still isn't really. If you see what's going on in the government, they're still stamping seals and and piles of paper in government, and I think that translated to much more human-oriented centered focus in manufacturing. How's this playing out there?
Well, first I have to tell you, we did get them to change from their stamps to use DocuSign this year. So it was a really momentous occasion when I can actually sign electronic documents from Japan. So that's a really good thing. But I will tell you, working with Japan, one of our members had, like I said, went to Japan on assignment. And did a lot of helping to educate folks there. But I think there's been a real shift, even in Japan, especially maybe more so on the vehicle side of things, and with the introduction of TRI, Toyota Research Group, and the understanding that we got to change to more of that type of workforce and philosophy. From an IT perspective. So I think there's a shift happening. I think it just happened here maybe a little bit before it's happening in Japan. But I think they're challenged with the same thing we are, with finding the workers that have the capabilities to bring them on early in their careers, and not having to source it to external companies.
Mm-hmm, mm-hmm. Joe or David, do you have any questions for Trevor or Martin and Grzegorz? No,
good.
Very good, very good. Well, I think we went over our time a little bit. We wanted to. I think we could continue this conversation on for quite a long period of time, but I wanted to. We probably should end it right now. I wanted to thank everyone for participating. Great presentations. We really gave us some insight on, of course, on the total breadth of IoT. When you start talking about the vehicles, what happens in before a vehicle is sold and after it's sold, and how it's on the vehicle so I think we had a pretty good discussion on those two different areas. And I want to thank you all for presenting and taking the time out of your day to do this. And I also always want to thank our affiliates for funding the program and keeping us going and allowing us to have these conversations. Again, thank you very much, everyone. And we'll talk to you. Our next conference is coming up in November 17th. It'll be our 13th annual, Inside China conference. So we'll be looking at things that have been going on in China from a variety of different perspectives. And as we know, things are not the same as they were just 12 months ago. So it's true. I think that's true everywhere in the world right now. So we're looking forward to hearing from people on that particular topic. So again, thank you very much, and I hope everyone has a good day.